Hello, hello. Hello, hello, hello. All right. Welcome, everybody. Hopefully you can hear me. Let's do a quick sound check and everything. Make sure you all can hear me tonight. Hope you're having a good Thursday evening. Cheers to you all. This is sweet tea. But hope you're doing well. Let's see here. Just catching up on just catching up on some of the comments. Andy, yeah, I'm still reading. I got an email, a real long email from you, but I also have a real long text message. And I like the text message regarding the question about, could I actually show, from here, could I actually do maybe a second part where I actually show the machining side of things and making the project and clamping options and maybe obstacles to run into and things like that. Very good suggestion. And I think I'm actually going to do that. So good on you for that. And also, yes, I'm still reading. There's still a lot more to read that I haven't gotten quite all the way to yet. Now, Mike Smith, I didn't get a chance to read your comment fully, but it says, cut a few boxes today and was very disappointed. Much head scratching. My fluid end mill measured out at, okay. Okay, so Mike Smith in the chat room was sharing with everybody that he actually cut a few boxes and things weren't coming out right, like his lids and stuff. And after much head scratching and everything, come to find out his bit was off, which kind of compounded the offsets and everything. And Mike, hopefully you were able to get that resolved, and hopefully you did another project and maybe a couple or one came out good. But yeah. Anyway, okay. So Tuesday night, we had a class for those of you that might be just joining me for the first time tonight and we're not here Tuesday. We did a class on CNC boxes, and my inspiration for the CNC boxes was this little box here that I picked up while I was in Rome in Vatican City. And this box happens to have, instead of a fitted lid, which is what our class was on Tuesday, this box has a magnetic lid, which that's a nice little touch and everything. Most of my boxes are all fitted lids, but tonight we're actually going to talk about magnets and things. And I believe it was Mike Smith that recommended a website that I check out about magnets. Mike, if that was you, could you tell me what the name of that website was again? Now, take a look at this little box here. This is olive wood, beautiful stuff. The box has a really nice profile on the side. And if we take the lid off and we look at the profile, it's just got a really nice little side profile. It's not just a typical square box. It's got a nice little side profile. Even the lid itself, let me get focus here. Even the lid itself has a small little profile, little lip on it. And when the two are together, it creates just a nice little elegant box. We're gonna talk about that. We're gonna talk about doing a side profile. Now, granted, the easiest way to do this is if you had a router table. Once your boxes are cut and everything, you could take the box over and run it on your router table and route the edges, you know. But what I'd like to do is I'd like to explore, actually, for those of you that might not have a router table, I have a router table, but I like to explore edge profiling with a router bit. Now, this technique is going to require some little bit out of the box thinking, if you will. The bits, the profile bits, the edge profile bits, they're typically long. The one that I've designed in here has an overall cutting length of about 2 3/8 inches. The box that I'm going to be designing tonight has a size of about 1.5 inches. Now, imagine that, you know, my box is 1.5 inches and my bit, the whole profile of this particular bit, I've been searching for smaller bits and stuff, and I could use a combination of bits, you know, more than one to create a unique profile, and I've done that before. But I'm looking at like just a simple, maybe almost the same kind of bit that you would make trim, base trim or crown molding with, you know, a profile bit. They actually have at Eagle America, shout out to Eagle America, they actually have box bits, box profile bits and stuff. But they're big, you know, they're designed for larger boxes and things. And we're talking, you know, small little gift boxes and things. Well, imagine if my profile is coming down only, you know, my box itself, the base of it's going to be about 1.5 inches. I'm not going to get the whole profile. So I got to make sure that where that profile is going to hit, the box is going to look the way that I want. If I'm using that single bit versus a couple of different bits. So the challenge to that is this is going to be a block of wood that this box is going to get cut out of. So I got to think about clamping. Number one is the profile bits typically are not plungeable. They typically don't have cutters on the bottom, so they're plungeable because they're typically designed for either cutting horizontally or vertically on a router table and running the wood across it or across the fence, right? I'm talking, you know, cutting around. So my box or my piece of board is going to have to be elevated in a way that it's supported, you know, it doesn't rock or anything. And when I cut the profile cut to cut the box out, I'm going to have tabs and stuff. So what am I going to do? How am I going to do an edge profile if I've got tabs? Because it's going to just cut the tabs out of there. So I'm going to have to use two-sided tape. And I'm going to specifically need to make sure that the two-sided tape is going to be really kind of concentrated in mainly, or, you know, I might have tape on all the edges of the board itself, but right where that box is getting cut out of, that there's some tape there that's going to hold this part, because I'm going to have to open up a channel around this box that my bit can come into. Now, I'm not going to plunge that bit straight down. I'm going to use a lead in and lead out technique in the profile toolpath, which means the bit's going to lead in away from the profile, and it's going to lead into the box, cut around, and it's going to overpass where it started by maybe a 1/2 inch, and then it's going to lead out and then raise up and everything. And so I've got some challenges to think about, and that's what one of the things like Andy was talking about was, hey, could you do a part 2 of the video and showing machining techniques and some of the obstacles you run into and how you clamp and things like that. And this is kind of going to be one of those projects where it's going to be a unique situation. If I wasn't doing a box or a side profile on this, then there'd be no big deal, you know, clamp it down, cut it out, use tabs, all that stuff. And then I could take it over to my router table and very simply cut the profile on it, you know, use your tools for what they're good for. But I'd like to experiment with cutting a profile on the CNC table if I don't have a router table. What happens if I don't have a router table or a handheld router or something? But there's 2 components to this. There's the box, the main box, and then there's the lid. Now, it's going to be a 2-sided project for the simple fact that on the lid, and the lid, I'm not going to, let me stop here. The box itself is going to be 1.5 inch thick material, but I'm not going to cut the lid out of 1.5 inch thick material. I'm most likely going to cut that out of a piece of 1/2 inch material or something around that, you know, maybe even 3/8. It's not very thick, you know, in itself and stuff. And so I'm not going to waste all that wood or try to cut the lid out of a thick piece of material and then have to figure out what I'm going to do. How am I going to mill it down or cut it on a table saw? I'm not going to deal with all that, because what I'd like to do ultimately is carve the top side, flip it over, and get my magnet holes, you know, put in there. And all depends on the size of the magnets and stuff. And on the box itself, I've got to get the magnet holes and things and all. And all. So there's going to be some challenges with this, and we're going to explore those challenges, and we're going to explore, you know, the edge profiles. But again, use your tools for what they're good for. The CNC is great for cutting out the parts and all that stuff, but taking it over to my router table would be much simpler and quicker. Instead of trying to use a long profile bit and be fancy with it and do it just one bit, I could use a combination of an OG bit, a box core bit or something, and I could create, you know, by those multiple smaller bits, I could create a very unique profile for the box. We'll talk about that a little bit later. Now on the lid itself, I'd like to do a 3D model. Now, many of you might have seen the thumbnail where I had the 3D model, and let's come over here and look at the 3D view. You'll see the 3D model. Now, this model was created basically from scratch, from a few vectors. I had a little picture of a dragon that was traced, and that vectors were converted into a model with the modeling software of the Aspire. And then I had a nice little ornate kind of JPEG image that I traced. And then I, you know, turned that into a model as well, and then a frame around it and everything. So this is what the lid's going to be. I'm going to make it kind of like a little Oriental themed box, if you will, you know, or something along those lines, you know. But we're going to, a good portion of tonight's class is going to be making this lid and everything. And most likely we're going to do it in 2 separate projects. Now, the reason being is because the box project itself is going to be a one-sided job. The lid is going to be a 2-sided job because of cutting the magnet holes on the bottom. Now, of course, I could very easily take a Forstner bit, you know, if I had a bit the same size of the magnets, and I could bring the lid over to my workbench and I could drill the 2 holes, epoxy the magnets in, and be done with it, you know. But I'd like to be able to use the vectors from the box to create the holes for the magnet and lid so they match up, you know, perfectly and all that stuff. But a good portion of the class is going to be on making this lid. There's quite a few steps involved to make this. And it's not the greatest looking model in the world. It's a neat little model. But, you know, it wasn't the best quality images and things. But I'm going to show you, hopefully, some techniques on how to work with what you got, you know, to create some things and stuff. And this was just what I came up with. All right. So all that being said, let's go back into our project here, and let's go back to the beginning, and let's get over into full screen. Now, we're going to go ahead. You're going to bear with me real quick while I, as a matter of fact, I'll put my camera on here so I'm talking to you while I go in and change my settings so the screen is bigger for you guys, my display settings. So bear with me a second while I do that. But hopefully you guys enjoy tonight's class, and hopefully we end up with something pretty cool. Okay, let's get back over to here. Okay. Oh, I'm sharing the wrong screen. Bear with me a second here. We did it again. I did it again. Oops, I did it again. There we go. All right, let's get things into view here. And let me real quick take a second. Jeff asked a question here. when doing a two-sided job, what other ways are there to flip the wood over and have it where it belongs other than using dowel holes? Okay. Well, it's kind of a trick question there, because you could basically block the box in, or the board in. You could put, some kind of fence on it, to have it in place, so that way when it flips over, it lands in the same place on the table. The only thing that is bad about that, and where the alignment holes come into play. Let's say, for instance, that my board, I have it programmed in my job as 7.5 inches. Okay. And let's say that I'm working from the bottom left corner of my board, and I have my fence on my table that it references. But let's say that my board on the table is actually 7 9/16. Or instead of 7.5, 7 9/16, or instead of 7 1/4, let's say it's 7 3/8, a little bit bigger. Well, from that bottom left corner that I'm starting from, my XY0, if I'm measuring from that corner to the position where I have my project and everything, well, when I flip over and reference that other edge, I flip it over and I reference it up against my fence thinking it's going to be in the same place, I'm actually going to be, because my board is actually longer than what I set up in the program, I'm actually going to be off by that distance. And therefore, it's not a good technique. The dowel holes really guarantee, the alignment pins really guarantee that it aligns up perfectly, because you're working off of those holes and off of the X and everything and all. Because when you drill those holes, even if your board is a little bit longer, wherever those holes are, when you lock them onto that pin, if it has to shift this way, to get onto those pins, it's going to shift that way. It's going to put us right where we need to be and everything. So I'm sure there's other ways. And if anybody has any other answers for that, please post it in the comment section, because I've never had great success by using any other option other than the alignment pins, but I've seen a lot of people do it. A lot of times, instead of doing the pins off an angle, you could do the pins right on the center of the material, or not. See, we're back to pins. You could measure your board, mark the center, and have two identical marks, and then make marks on your wasteboard so that when you flip it over, they land in the same spot. It's almost like using alignment pins without using alignment pins, if you will. But it might not line up with your fence if you're using a fence like I do or something. It could be a little off or something and all, because that board could be a little longer on one edge versus the other. And so that's a tough one, Jeff. It really is. There are other ways of doing it, and you can, on YouTube, there's people doing two-sided projects and they have their own techniques. I've never had any success other than the alignment pins, and some of the people in the class tonight might do two-sided jobs and they may use a different technique. If you do, share it with us, guys. That'd be great, and girls and stuff. But hopefully that somewhat, it didn't really answer your question, Jeff, but that was my only explanation that I have. All right, let's get back to the project at hand. Now, this project that I have set up here is going to be basically for the box lid. And we're going to look at the box lid. It's going to be a double-sided job, two-sided job. And the width of this box is going to be 2 3/8 inches wide. The height of the box, how long the box is and all, is going to be 3.5 inches. And the lid itself, I'm going to most likely, I want my lid to not be very thick, and the model itself is not very thick. So I'm going to say that the thickness that I would mill this out of would be probably about 3/8. Might even be thinner. I don't want too thick of a lid, but it all depends on how much, how much material is getting milled away for the model and all that stuff. So for right now, I'm just going to say 0.375. Okay. Now I will be working off of my wasteboard as my Z0. You can work off the surface of your material however you want to do, but I work off my wasteboard, and I will be starting from the bottom left corner of the project because my wasteboard has a fence in it that I use, a 90-degree fence that I use that my board's reference against, and I will be flipping along the Y-axis. It doesn't matter if you flip along X or Y. It's just my preference. And again, as I was talking about, Jeff, that if I say my board is 3.5 inches wide and it's 3 9/16 or whatever, and it's not 3.5, it's a little mid over. When I flip it over, if I reference against my fence, everything's going to be shifted by that margin, and it's going to throw things off. I won't be perfectly aligned. So that's where alignment pins really come in, because they're going to force me to align. Okay, anyway, enough of that. All right, so that's going to be the two-sided job setup, 2 3/8 by 3.5 on the Y basically, and 3/8 of an inch thick. That's going to be for the lid. Now we're going to open up a second instance of Aspire because I'm going to do it in 2 jobs because the box itself is going to be made out of thicker material, much thicker material. I'm going to go with 1.5 inches. And if the lid and the base and all were both, if I was working with a 3/4 inch board, just like we did on Tuesday night's class, I'd be cutting the lids and everything right out of the same board and all. But in this case, my lid's going to be very thin while the box is going to be very thick. So I have to do it as set it up as 2 separate projects. So on this project, we're going to have the same 2 3/8 by 3.5. It's going to be 1.5 inches thick material, and I will be referencing off my machine bed, my wasteboard, and I'll be working off the bottom left corner. Now, let's go ahead and click OK. Okay. Now, I want to go back before we get into the base of the box and everything. I want to go back to the lid, which is this one here. When you're creating models from scratch and stuff, one of the things that what's ideal is that you're creating models in the highest resolution possible, this modeling resolution down here. At the very least, use the very high option, which is 4 million pixels. But many of you may or may not know there are 2 other additional choices here, and an extremely high and an ultimate high or whatever. We'll see what those are in just a second. And when I'm creating models, I generally tend to create models in the second to the highest option. Now that's going to slow down your previews dramatically because it's using, 10 million pixels to be created and things, or 8 million pixels, I believe. But it's going to make the model much smoother, because if there's any slight pixelation in your model resolution in that 3D view, because of the low pixels and things, that is going to transmit and translate to the quality of the cut, the quality of the model itself. So anytime I'm working with a model, at the very least, I'm in the maximum setting, which is the very high here, 7 times slower of the 3 main options. But we also have the option of, let's go in and create another Aspire here. If I hold down the Shift key, when I click create a new file, if I hold down the Shift key while I do that, in the job setup here, it gives me 2 additional options: extremely high, which uses 8 million pixels to generate the 3D view, and then maximum, which uses 16 million pixels. Now, maximum 50 times slower. Now, that's not carving time slower. It's to generate that 3D previewing your toolpaths and things like that. So it's got a lot of pixels that it's generating all. However, if you're in the if you have your Aspire software to make models and you're making models from scratch, you typically want to make it in one of the two. So you're making your model in the highest resolution with less pixels, so that you get the best quality model that you can get. Now, that being said, when I created my model of the dragon here, I wasn't in the maximum. I wasn't thinking last night, it was late. And so I wasn't thinking, and I was like, oh man, I was in a lower resolution model. So what I may end up doing is I'm going to keep this one open for reference and stuff, so you guys can see the original vectors and the vectors that I used and all that stuff. But I'm going to go ahead and create another job, and I'm going to use the maximum option of extremely high, and that's going to give me a better quality model that gets created when I do this final resolution. The only reason why I'm hesitant about using it during the class is if we're going to preview a toolpath to see what it looks like when it cuts and things like that, it takes forever. Because it's using so many pixels. So I'm kind of hesitant about doing that. But just know that if you are going to create your lid or your model, or create a model in general, forget the boxes, set them aside. If you're going to create a model in general, you want to be able to create in the extremely high option or the maximum to get that best quality model. Because see, when you create a model in Aspire, unlike VCarve Desktop and Pro, when you create a model in Aspire, you have the ability to export. You have the ability to export that model out as a 3D clip art and add it to your library. Now it's going to be a high quality model that you added to your library. You have the ability to export it out as an STL if you created a model that you want to put up for sale for people to digitally download and make some money off of it. You know, if you're going to create models for selling and stuff, you want the highest quality model that you can get, and people want to buy the highest quality model. So, you have the ability to create these components and export them out, and you want to export them out in a very high resolution and everything. What I'm going to do is I'll most likely end up recreating this model in a higher resolution. But for tonight's class, I'm not going to, because of the simple fact that if we're previewing toolpaths and stuff, I don't want to sit here and be spending a whole lot of time just because I want to see a toolpath it taking forever because of the resolution. But just know that after tonight's class, I'm going to redo this in a higher resolution when I have more time, and I'm going to make that. I've already made it once, making it twice tonight. Third time, I should be able to breeze through it like clockwork. All right, so we're going to go ahead and close this, but I just want you to know about those additional options, extremely high and maximum. And you obtain those, or you get access to those by holding your shift key down when you click create a new project. All right, let's get out of there. And okay, so I have my lid file here, and I've got my base file here. Okay, all righty. Let's start with the base. It's all about that base. All right, let's start with the base. So first thing I'm going to do, save early and save often. I'm going to go ahead and save this this file here, and I'm going to call it CNC Box Aspire Base. Look how original that name was. That way I know that file is already in my library, and we'll be good to go. Okay. So now, first thing I want to do is on my box, and let's pop back to me for a second. On my box, notice we have our outside edge, then we have our inside pocket area, and then we have, you know, these areas here where the magnets are going to be. And we're going to basically kind of emulate that in a way. Now, one of the things you have to be aware of is if you're going to do an edge profile, the edge of the box, imagine that it's, you know, a square block of wood. How much is that bit going to cut in to be able to create that profile? And if you offset your vector for the inside pocket, make sure it's offset far enough that when the edge profile comes in, you still have a good amount of wall left for your box, that it's not real thin. Now, the bit profile that I'm going to be using, let me get back over here and let's pop this back up. The bit profile that I'm going to be using, and let's come into original, not that one, box profile, and pop up here. Oh, let me hit OK on there. Let me select that vector, both vectors, copy. I'm going to go back into my box file, my base file, and let's paste it. And let's go ahead and I'm going to hit F9 on my keyboard to get it on my screen here. Now, this profile, and I'm going to hit the number 0 key on my keyboard to rotate it 90 degrees. But from the upper edge of this profile to the lower edge of the profile, that offset distance from, let's do a horizontal measurement, from this point to this point, that offset distance is 0.2813. So a little over 1/4 of an inch. Now, that means that when my bit is coming in to the edge of the cut of my board to create this entire profile, it's going to be, to get that entire profile and to get a nice profile and all, it's going to be at a minimum 0.28, a little over, 1/4 of an inch. But I'm not going to just skim my board and all. I'm going to take a little meat with it. So at a minimum, my edge of my box, 0.3 or to 0.31 inches, basically 3125, 5/16, if you will, 5/16 of the edge of my board is going to get milled away up here at the top, which is 0.3125. And that's going to be able to, that's going to allow my bit to take, whatever meat is necessary to create a nice edge profile and everything. And so I've got to be mindful of that. If I'm going to do an edge profile on my box, I've got to be mindful of that when it comes to creating the offset for the inner pocket. If I don't create my offset far enough in, well, when my edge profile comes and routes off, I'm going to have a big old cavity right here, big old opening in my box where I milled away the wall. So you got to keep stuff like that in mind. Okay. When you're choosing the bits that you're going to choose and everything. So now I'm going to hit 9 and I'm going to get this back. Now, unfortunately, in Vectric software, Desktop Pro and Aspire, you can't see an edge profile cut when it's created, like what the edge of a box is going to look like. I can't show you in the 3D view an edge profile. It won't show it. It just won't. It's one of the things that I wish it would do. But I can show you what the profile is going to look like by running it across the top here and giving you a preview. So let's go ahead and do that real quick. I'm going to draw a line on the right side of this board from one top to bottom, basically, space bar to finish. And I'm going to go over to my molding toolpath. And I'm going to select that line first. And then I'm going to select my profile. Now notice on my profile, I don't have this vertical line created. I don't need it. Some profiles you do. On this one, particular one, I don't. So I don't need it. I'm just going to have those two selected, and I'm going to hit calculate. Okay. All right. So let's preview this toolpath. Okay. And let's go ahead and turn this box up on its end. Okay. Now, imagine that you're looking at the side of the box. Okay, so this is what this edge profile is going to be. Now, this particular edge profile in its entirety is 2 3/8 inches tall. Well, I'm already running into a problem. My box height is only 1.5 inches, right? So that means from the bottom of that bit up 1.5 inches, that's going to be basically what my box looks like. I'm not going to get this upper profile unless my box is elevated in some way that I can bring that bit down and go from the top of the bit down 1.5 inches. But then I'm going to lose, a certain section of the lower part of this profile. Ideally, I would use this profile bit for a box that's the same height as the bit, or and do that so I get the nice full profile, But for me, what's going to happen is if I were to measure, if I were to take and put a guideline, I'm dragging a guideline from the ruler over here on the left. If I were to take my guideline and snap it to the bottom of this bit, that is the bottom there. And if I were to make a relative guide, negative, since I'm moving to the left, negative 1.5 inches away, then this is going to show you where that, what my box is going to look like. So basically at the top of my box, it's not going to get all of this profile here. It's going to get this lower profile. So maybe a little bit bigger because I'll probably have it go past the bottom of the box a little bit. But so the top of my box is going to kind of curve in and everything. So if I were to cut the vector, if I were to go into node editing mode and cut the vector right there at that spot, and I were to do that same edge profile again so you could see what it would look like. Let's go back into here, go back into my molding toolpath. And if I were to come in here and hit calculate, now, mind you, let's reset this. Ignore the top part of this. This is all not going to be here. Remember, my box is only 1.5 inches. So if I were to preview this cut, then my box is actually going to have this shape, which is, imagine now, mind you, this top part would be gone. That's not part of the box, which in itself is not very attractive, right? It's not, I mean, it's cool and all, but it's not very attractive. So, all right, let's come back here. Let's undo that cut, Control Z, and let's go from the top of the bit, delete this guide here. And if we go relative guide, this time positive, because I'm going to the right, calculate, and I take and cut the vector here, and I go back into that swept profile toolpath, and I select my vector, hold down my shift key, select this top part, and hit calculate. Reset that preview and preview the selected toolpath. Okay. Now, again, the top part is waste, so we're looking at up here. Okay. Probably about this straight away here. this is what the edge of my box is going to look like. So I'm only getting that, you know, that look there, which basically, let me, you know, that's just this top section here. And notice one thing. Notice one thing that occurred. Look at my 3D view. Okay. Look at the 3D view and look at the profile. This is the top. This is the bottom. So that means that this profile here, right here, if I go back in here, if we look, it started here and it's cutting in this direction. Well, if I reverse this, because this is the bottom and it's going, you know, inward. If I reverse this, right click on that and reverse the direction, so it starts from here, and I calculate this, reset the preview and preview the selected toolpath. That's what my box will like. Again, ignoring this top part here and everything. So either way, this bit is going to be tricky for me. I've got to find a happy medium if I want to use this bit. And I'm not 100% settled on this bit, but I just want you to know, I want you to understand the obstacles that you got to face when you're going to do an edge profile. If your stock is not, if your bit is much bigger than the stock and all, you're only getting a part of that profile, you know, not the whole thing. And I don't want to beat it to death. I think you guys get it, and guys and girls get it and stuff. So for me, ideally, it would be nice to find, if my box is going to be 1.5 inches, it'd be nice to find a profile bit that is within that range that I can use maybe a combination of more than one to create a nice box profile. But nevertheless, I'm still going to show you how to create the toolpaths for the profile so you can, so you know how to do it. Even though that I'm only going to get my side of my box, if I use this bit, is not going to come out the way I desire with that nice little look and that foot type, you know, bottom and all. I'm most likely not going to use this bit, but for example purposes and training, it'll be fine. All right, enough of that. Let's get into this. And before we get into this, let me delete these guides here. And let me delete this line. And let's take a pause for a moment to answer a couple of questions. I got a question from Robert and I got a question from Jeff. So first off, Jeff says, can you create a model in one of the lower res, and when you're done with it, in some way change it to the highest without starting over with the model? No. So whatever resolution that model was created in and that file was saved in, that's the resolution. Even if I took that model that I created in a low resolution file and I brought it into a high resolution project, it's still going to be the low resolution model that I'm importing. Just like if I went to eBay and I bought a model and the creator created their model in a very low resolution, a lot of polycounts, I'm going to get a lot of triangulation and stuff in that. Just because my resolution in my 3D view is set to high, I'm still bringing in the quality of the model that was created. And the same applies with us that create models in Aspire. If we create it in a low resolution, that's what it is. You cannot take a model and convert it to a high resolution model. You have to create it as a high resolution model. Okay. All right. Great question, Jeff. Now, Robert follows up and says, if you model a project in a higher resolution and export it, will the receiver be able to view it in a lower resolution? Absolutely. But the thing about it is, Robert, they're going to be able to view it in a lower resolution, but the model itself is going to be a higher resolution. Now, that being said, the user, you know, one of their things is if they use the standard resolution, which is like 1 million pixels, if they import my high resolution model or your high resolution model into that low resolution project, when they're in their 3D view, they're going to have a slight amount of pixelation. The toolpath that's being created is being created off the model in the file, and it's going to pick up some of that pixelation, and it's going to be transfer the quality cut. No matter how high quality you made the model, if they're creating their toolpaths in a low resolution, it's going to translate to that. Now, it's not going to be as bad as if it was a low resolution model. It's a high resolution, so the pixelation is going to be very limited. But still, they're going to want to. They don't have to create their project in a high resolution. The standard high is or very high, I think it's called, is good enough. It'll give them a nice clean resolution and everything, and all. But so yes, they're going to be able to view it in a lower resolution. It's going to be good quality, very good quality, but there's going to be a slight amount of pixelation because they're low resolution and everything. And the toolpath is going to pick that up. It's going to pick up on that. If I take a model off a design and make that's made in very high resolution and stuff, and I bring it into my project and I'm working, that's why, when you set up your job for a 3D model job, you want to be in a at least a very high resolution when you bring that model in. Anytime you're working with a model, at a minimum, you want to be here because you want the best cut quality possible, that you can get. But if I create my job in a standard resolution, which is 1 million pixels, and I bring in that model that I just spent $25 on, I'm going to get not the best cut quality that I could have got if I used a higher resolution. Hopefully that answers your question. But yes, they're going to be able to view it. Okay. All right. So thanks, guys, for those couple of questions. You guys keep your questions coming, and I'll take breaks periodically to do my best to answer them. Okay. Real quick, Mike threw out it's K&J Magnets. He told me to check out on Tuesday night. He said, hey, if you're talking magnets, check out K&J Magnets. So I'm definitely going to do that, and I wanted to share that with you guys. He put it in the chat room, K&J Magnets. So look them up, check them out, see what they have to offer. Okay. All right, let's get to business here because I'm rambling on, but I'm trying to, this is important. I'm trying to just pack you guys with some information, just food for thought. I'm trying to get you to think a little bit, about all of these things because, one of the users asked me about obstacles and stuff, and I'm trying to kind of verbally talk about those obstacles. And one of them is if you're going to do an edge profile, you got to think about that stuff. Okay. So I'm going to go ahead and I'm going to create a border here, a box boundary, should I say, rectangle. And it's going to be the same size as my box is going to be. And that's going to be basically my profile there. And that's what my bit profile is going to follow. That's the rectangle there. Now I need to offset this inward. And the thing I have to consider once again is that offset distance, depending on how wide or how big that profile is, how much meat's going to get milled away on the side of this box to create that edge profile. And in my case, it's going to be 5/16 of an inch. So when I offset inward, when I offset from my pocket area in here, I need to be at least at that 5/16, which is 0.3125, plus however thick I want my wall to be, equal sign. And so that my offset is going to be about 0.565, a little over half an inch offset. And of course, not outward. We're going to offset inward. And I want sharp corners. So offset inward, not outward. And so with this size box, with that offset, knowing that there's going to be an edge profile, look at the size of my pocket, my cavity, where the goodies are going to go. It looks like, man, there's a whole lot of wood there. But when in reality, when that edge profile is done being cut, my wall is going to be only a 1/4 of an inch thick, at the top. Now, if we look at the size of my cavity here, my rectangle that's going to be there, we look at the size of it, I'm about 1 1/4 by 2 3/8. Okay. And if I need a bigger cavity, then I need to make a bigger board. Know what I mean? You with me on that? Good. Okay. Now, for the purpose of this, since I've kind of picked out my box size, and everything. And I'm making a small little trinket box and all. I'm going to be fine with this. But there's always a but, right? But hold the phone. Technically, if I offset outward 1/4 inch, 1/4 inch, right? That's what my final box dimension is going to be at the top, where the lid's going to go, right? Where the lid's going to go. I got to think about that. So what's that size? That size is 1 3/4 wide by 2 7/8. Well, let's go back to my lid project and let's let's turn on some vectors here for a minute. All right. This is my lid. This is the inside of my lid, the decorative part, you know, right here and everything. Well, I made that lid 2 3/8, the size of my box, you know, like before the edge profile. So that means I'm going to have to reduce everything down to fit that, or my base box board is going to have to be bigger so that I end up with a 2 3/8 inch by 3.5 inch surface for my lid to sit on. You with me? So we got some thinking to do. So what does that tell me? That tells me if this is my lid size here, then I'm going to take this and offset outward by that 5/16, 0.3125 square corners. And this is what my project board size should be. So let's look at this. And my project board should be 3 inches by 4 1/8. Okay. So we're going to go in and change that. All right. So we got 3. What'd I say? Dadgummit. Did I say 3 by 4 1/8? Hold on. Let's do that again. Yeah, 3 by 4 1/8. Man. All right. So I got to change up some things. 3 inches by 4 1/8. Okay. So let's go ahead and get rid of these vectors here. We'll keep this one. Let's move this out of the way. Let's get my new border and F9. I'm just going to hit F9. And by the way, that's the alignment tool, center to material. F9 is the keyboard shortcut to center to material. Okay. All right. So from here, I'm going to offset inward my 3 1/8 or 5/16, but I'm going to add my 1/4 inch because I'm creating the vector for the inner pocket. So I'm going to add my 1/4 inch back to that, and I'm going to offset inward. There we go. So now when my profile gets finished getting cut here and I have my 1/4 inch wall, I'm still going to have a 2 3/8 by 3.5 inch box when it's all said and done for my lid. Okay. So stopping right there, by a show of hands, yes or no, how many of you did I lose, or how many of you understand exactly what thought process I just went through to come to this conclusion? Yes, you understand. No, Lainey, you lost me about an hour ago. Just get some interaction from you guys. Okay. Alrighty, Aphrodite. Now, the magnets, let's take a pop over to K&J Magnets. Let's see what size magnets they have. If I were to order some magnets off of K&J Magnets, let's see what they've got, and that will give me an idea of what my magnet holes are going to be. So we're going to go, I'm going to go K&J Magnets. World's strongest magnets. Now, hopefully they have little neodymium or rare earth magnets and things like that. Hopefully they're not just big old industrial magnets and stuff. Okay, they're big. They're all right. Okay, so they do have some little ones. Good. Disc and cylinder magnets. So that's where we're going to go. Disc and cylinder magnets. And then they also have grade N2. I don't know anything about magnets, ladies and gentlemen. So I don't know what the different grades are. But if we back up one page real quick, they have this grade N52. Not sure what that means. So I'm going to assume that disc and cylinder magnets are going to give me what I need. And then I'll have to do some research as to magnet polarity and how strong it is and blah, blah, blah. Okay. So hopefully these are some strong magnets. Man, these are long magnets. I don't need them that long. And I really don't need them a whole lot big, but that's an 1/8 inch diameter. Let's see what they got. Let's 1/10 diameter. 1/10 diameter. I mean, is that the, okay, hold on a second. Diameter. So I'd like at least a 1/4 through 3/8 inch diameter. Let's see what they've got as far as options with that. There we go. All right, we're getting somewhere now. Let's see here. I'd like to have that magnet have a little bit of depth to it. So 3/16 inches thick, 1/8 inch thick. Let's see what we got here. So 5/16 looks to be the diameter. Wow. Okay. I ain't got nothing in between. Let's go 1/8 through 1/4. 5/16 isn't too bad, but that's kind of big. I don't want to take up that much. Here we go. 3/16. All right. By 1/32, by 1/32, by a 16th, by a 16th. Come on, give me a. Here we go. Here we go. So a 3/16 inch by 1/8 inch thick magnet. 25 cents. Not bad. So that's going to be the size. If I were to do my box, that's going to be the size that I'm going to work with. Okay. So 3/16 inch diameter, 1/8 inch thick. 1/8 inch thick. Okay. Cool. That's a pretty in-depth site as far as magnets go. So it's going to take a little research and everything. I just want to show a little glimpse of that. Thanks, Mike, for sharing that and everything. And we'll go there. All right. So real quick, I have my new box size. This is my new board size, which is 3 inches by 4 1/8. I have, because I'm doing an edge profile, I have offset it the distance of that edge profile, which is 5/16, plus what wall thickness I want before my pocket is created, which is a 1/4 inch is what I want. And so that 5/16, 0.3125 plus 1/4 gave me the offset of about 0.56 and some change. And that gives me my inner pocket vector. Andy, hopefully that answered your question as far as can you repeat the offset size. I'm offsetting 5/16 of an inch in because of the router bit profile, the edge profile that I'm going to be using, plus how thick I want my wall, the 1/4 inch, and that what gave me my inner box. Okay. All right. Okay. Now, so we just said that I'm going to use a magnet that is a diameter of 3/16, 0.1875. Okay. And I'm going to just pop them there for just a moment, the two holes and all. Now, I would like to emulate, let's pop back to me for a second. I kind of like the way that this is designed where the pocket kind of swoops in where the magnet is and everything. I kind of like that design. It's pretty cool. So that's what I would like to do. I'd like to, have this kind of come in around this magnet hole. So what I'm going to do is I'm going to move this magnet inward from the, I got it centered on the edge of my pocket right now. I'm simply going to move it along the y-axis, and I'm going down. It's a negative number. Positive is up. So I'm going to go negative from its position. I'm going to go 0.3. Okay. And this one's going to be moving up, so it's going to be a positive 0.3. Okay. Now, I want to make sure that these holes are centered, and they should be because I snapped them to the center of my box here, but just I'm going to double check. So I'm going to check off this box right here last, and I'm going to go to my alignment tool, and I'm going to align left to right. They didn't move, so they are centered. Wonderful. Wonderful. All right, now my pocket's going to come and it's going to sweep around this and then, back over here on both the top and the bottom. So what I'm going to do to help me create that sweep is I'm going to use an offset. I'm going to take my 3/16 inch hole here, and I'm going to offset outward. And outward, basically, I'm offsetting the amount of how much meat I want around the magnet. And let me get back to full screen, but the reason why I'm still on me is because I want you to look at the meat that's around that magnet. It's not very much. I would probably say maybe 1/8 of an inch, maybe 3/16, but there's not a whole lot of meat around that magnet, right? So let's go ahead and let's zoom back into the program. And basically what I've done is I'm going to undo this. Okay. I tapped my 3/16 inch diameter holes. I centered them on my rectangle, and I moved them along the y-axis. Down is a negative number, so I went negative 0.3. And up is a positive number, and I moved the same distance, positive 0.3, to get that position. Now I'm going to offset these by the amount of how much meat I want around them. How much meat. And I think that I'm going to go, me personally, I'm going to go about 3/16 of an inch. I'm going to click offset. No, that's too much. Too much. Let's go 1/8. 1.125. There we go. The only thing, just make sure it's enough that when you're drilling this hole, it doesn't blow out, right? You know what I mean? Okay. So now that I have that, now I need my box to kind of, I don't want it to just come and just square right off to this and everything. I'd like that nice, a nice sweep into here. And so I'm going to take a arc tool, and I'm going to snap to about the center there and create a nice little curve. Okay. I'm going to take and draw a line right here for a minute. And I'm going to take this curve. I'm going to select this line, and I'm going to go into my mirror tool, and I'm going to flip it about that line so it lands in the same spot. Okay. Now I can delete that line. Now I'm going to take both of these curves here, and I'm going to mirror them and flip them about job center vertically. So they land down here. Okie dokie. Okie dokie. All right. Now I'm going to do some trimming. Take my scissor tool. Let's trim this away. All right. Let's trim this away. Let's trim this away and trim this away. All right. So that is going to be my box pocket. You with me? Everybody with me? All right. Okay. So I've got that vector created. That's going to be my pocket area. Now, my box, I'm going to be using a 1/4 inch router bit. You can use smaller router bits, but I'm going to use a 1/4 inch for this and stuff. Actually, I'm going to use an 1/8 inch bit, so I only have to change bits one. I'm going to use an 1/8 inch. Hold on a second. No, I'm going to use a 1/4 inch bit. I'm going to use a 1/4 inch bit to pocket this out. And so I need to put some radiuses on these corners. So I'm going to use my fillet tool. And I'm using an 1/8 inch or 1/4 inch bit. So the radius is 125. The radius of that tool is 125. I'm going to do a normal fillet. And I'm going to not close the tool. And I'm going to come in here and radius. Okay. So now the pocket for my box is finished. So that's what the inside of my box is going to look like. All right. Now, mind you, it looks real thick up in here, right? But remember, most of this meat is getting milled away. Okay. It's getting milled away. And I'm only going to have a 1/4 inch wall all the way around. Very thin wall. Up at the top, then it's going to get wider based on the profile, you know, and stuff. So just remember that. So if you're looking at it and it looks really odd, like, man, that's a whole lot of wasted wood. Why isn't the pocket bigger and all blah, blah, blah. This is going to get milled away. So if I were to offset this inward, my 5/16 to just create that vector. Okay. Visualize this, as being my box. That's what the box is going to look like. You know. All right. So I noticed when I clicked on this that I had an overlap. Overlap means that my end of my line doesn't reach. You know, it kind of overlaps and stuff. Can't have that. So I'm going to come into my trim tool and trim that overlap away. Same thing over here. Trim that overlap away. Same thing down here. Trim that overlap away. And here. That overlap was there from when I created the two arcs. I overlapped them into the lines. And I could tell that the vector was not closed because when I clicked on the vector, only one part of it got selected. It didn't select the whole thing like it just did. And that made me look up here and I could see the overlap. Okay, so now we basically ignore this. This isn't going to be used for anything, and this is just for reference purposes. We now basically have our box pocket area. We have our magnet holes, and we've got our profile vector for the profile cut. That's all there is to the base of this box. We can create the toolpath. So let's go ahead and delete this toolpath for right now. First things first, I'm going to take my 3/16 inch magnet holes here, and I'm going to create a pocket toolpath because I'm going to be using an undersized bit to cut them. I want a perfect hole. And when you want a perfect hole, I generally don't recommend drilling a drilling toolpath with the same diameter bit, because as it's plunging down, when it first makes contact with that solid block of material, it could have a tendency to travel a little bit, wallow out the top of the hole, creating a sloppy hole at the top. If I want a very nice, precise hole and everything, I'm going to use an undersized bit and I'm going to pocket out to the size that I want. And in my case, I'm going to be using that magnet that had a thickness of 1/8 of an inch. And so I'm going to go ahead and mill 1/8 of an inch deep with 1/8 of an inch end mill. And it's going to be an offset. Round and around we go. And this is going to be my base magnet holes. 0.125 mm. All right. So make sure you guys are with me and everything. And then Jeff, I'm going to come back to your question here in just a moment. Let's go ahead and get this back inside here so we can see that. All right. Next toolpath is going to be my inner pocket. My inner pocket. And the inner pocket is going to be a pocket cut. And it's going to cut down 1 and 1/8 inch deep with a 1/4 inch end mill. Go ahead and this is going to be my base inner pocket, 0.25 end mill. Okay. So we'll preview those two real quick. While that's previewing, let's go ahead and jump over to Jeff's question. If that offset is 5/16, are you going to take that off of all 4 sides? So so shouldn't that be twice as much for both directions? Very good question. We'll take a look here in just a moment there. No. I understand your question, Jeff. I understand exactly what you're asking. You're saying, hey, if you're taking 5/16 off this edge and 5/16 off this edge and everything, wouldn't this be twice, and off this edge and off this edge? Wouldn't it be, since it's coming off both edges, wouldn't it be twice the size to, so everything fits and everything? Well, if we look at the size, if we pop back over to our drawing tools here, if we look at the size here, it takes off 5/16 all the way around. And when it does, the size of my remaining box here is going to be the same size as my lid, 2 3/8 by 3.5. You would not double it. I think you're thinking like almost like if you were on a lathe or something, or I can understand exactly why you would think that, and everything, thinking, am I not doubling it if I do 5/16 over here and 5/16 over here, blah, blah, blah. But when I offset this outward, or sorry, offset this inward 5/16 of an inch and everything, my bit is going to be removing this material here. It's going to be removing this material, this and this. And what it's going to leave me with at this vector line is the same size box that I need for my lid. Okay. So I would not double it. No. So hopefully that answered the question. Okay. All right. So basically we've got our little magnet holes there, and we've got our pocket. That's going to be our box. Put some nice felt in there, do some flocking. It'll be pretty. Okay. Now, here's the shame of it all. I want to be able to do a profile toolpath with the form bit. If we go in let me select, I'm just going to do 1.5 inches. Just, let's go a little past the bottom of it. So I'll go 1.5625. So we'll go 1 9/16. I would love to be able to show you guys this profile. And I would love to be able to just select my bit and choose my box edge bit, which is this bit right here, right? And I could in the software just for preview or whatever, just to show you, right? And I could come in here and we'll get back to the leads and ramps in a minute, but let me just calculate this for a second. And I just want to show you what our limitations are. If I preview this toolpath and everything, and first of all, don't be an idiot, Laney. I got to offset inward my 5/16. Let's try that again. If I preview this toolpath, we can't in the Vectric software, it doesn't show undercuts, and so I can't see the actual edge profile of what it's going to be. You know what I mean? I can't. It's not going to show me. We don't get the chance to see that. That's why I showed it to you earlier by carving across the top and everything. All right. But this is what my top of my box would look like, as far as the top goes. But unfortunately, we can't see the edge profile. Maybe one day down the road, Vectric will create a way that you can see an edge profile. You never know. They're always making some awesome changes and stuff. But as of right now, we can't see undercuts. That's why we can't add bits like dovetail bits, keyhole bits, slot cutting bits, and things like that. That's why we have to use a dummy end mill, and all. So the only thing that I can do is now I am able to create the actual bit. I was able to actually create the profile bit and add it as a form tool. No problem there, right? I can add that tool to my tool database and everything. Because it's an edge profile and stuff and all, it's just like a Roman OG bit or a round over bit and everything. So I'm able to add it in there. The only problem is that I'm not able to see the actual cut in the preview. Okay, but I would actually choose it in here. And basically how we did this on Tuesday night. Let's come in here. And 0, 0. You always draw the right side of the profile of the bit. And let me add these two together. I'll cut them back apart in a minute. Join that together as one vector. You always draw the right profile of the bit to scale. And when you're adding it to your tool database, it would be a form tool, and it'll add that in there, and then you can come in and put in your settings. Okay. Now, I do not want this bit stepping down. Okay. I don't want it stepping down till it gets to that profile. I want it to do one full pass. All right. Stepping inward is a different story. I might want it to step inward, and do multiple passes where it goes inward and all. But my pass depth is going to be the cutting height from the bottom of the bit to the top of the bit. In this case, 2 3/8. The step over, if I do have it step over, and work its way in and stuff, I will have it step over, a small amount. Now, in a profile toolpath, that being said, in a profile toolpath, let's discard those changes. In a profile toolpath, we have what's called do a separate last pass. Now, a separate last pass means that I can have my bit come down and cut a certain distance away, but on the last pass, it's going to move over to where it should cut, and it's going to cut the full pass. Well, the only problem is it doesn't move over the way that we need it to. It's going to come down and it's going to, plunge down, and I don't want it to plunge down, tearing up my wood all the way down. And plus, this bit is not a plungeable bit. It doesn't have a cutter, on the bottom. It's a surfacing bit and everything. There may be a cutter on it. I'm not sure, but I don't think there is. A flute blade. So I can't use the separate last pass on here. So I have to use leads. And the leads is basically I can use a straight line lead where it comes straight in, cuts around, and then leads out if I want to add a lead out, you know. I like using the circular lead where it kind of sweeps in and then around and then it sweeps out. And rather than sweeping out right where it swept in, I have it do an overcut. So it goes past where it started and then it sweeps out. So for me, on the lead of this profile toolpath, I'm going to have it lead in at a radius of 2 inches. The lead length, it's only going to be 1 inch from where it's going to need to cut from, but it's going to radius, going to be a 2-inch radius. It's going to come around and cut, and then it's going to overcut where it started from by 1/4 of an inch before it moves away from the board, before it raises the Z up and moves on to other things. I do not want this thing coming at the start point of the cut, coming around at the stop point, and then just raising up right there and, turning a nice little groove in my board or anything like that. I want it to lead away from the project before it raises up. So that's leads, lead in and lead out. Okay. Now, my lead distance, the one thing I have to keep in mind is that my bit has a total diameter of 1.25 inches, right? And so my lead in, if I only have a 1-inch lead in here, then my top of my bit is going to be right, where it's got to be, in all. So what I'm going to do is I'm actually going to have it lead in at 1.3 inches or the lead in and out 1.3 inches away. All right. Now, I'm not going to use tabs. I'm not going to use tabs for this because tabs are going to be useless. When that profile bit comes around and cuts it, it's going to cut. I'm going to use double-side tape or hot glue, something that's going to be pretty stout in holding this. I might even very well, in the bottom of that pocket, since I'm going to be putting felt in here and I'm going to be putting cork on the bottom and all, I might even put a screw right in the middle and screw it into my wasteboard so it doesn't move. I don't know. But I think double-side tape would be strong enough because I'm going to be coming in passes and stuff, and I'm going to show you how we're going to do that because we're going to do multiple profiles, and we're going to work our way in to our final cut. We're not going to take this full 5/16 inch cut in one pass. We're going to take probably 1, 2, 3 passes inward. And when I say passes, I'm not talking about depth. I'm talking about cuts, how much material I'm removing. I want to move a small amount of material. It's a good sized bit, and I don't want to be aggressive with it and everything. So I got to work my way in and everything. So I'm going to have 3 tool paths, and the allowance offset is going to be, I'm going to divide this number by 3 ultimately when we get back up to it. And I'm going to do 3 profile tool paths ultimately leading up to my first pass, the second pass, which is multiplied by 2, and then the final at 3, 1, 2, 5. So I'm taking those small bites. You'll see that here in just a moment. But anyway, so I got my lead in, lead out. All right, let's go ahead and now go back up to there. Nothing else down here. Let's give it a name while we're here. This is going to be my edge profile. Okay, my edge profile. Yeah. And that's going to be my 1.25 edge bit, box bit, whatever you want to call it. And let's go back up here. I don't want to hit calculate yet. On my allowance offset, I need to divide this number. I want to do 3 passes, so I need to divide this by 3. And what this means is let's draw a box here. Okay. When my bit, and let's take my bit here, And let's mirror it. Let's flip it left. Okay. And let's group that together as one. Or join it together, not group it together. All right. Right now, if I have no offset, I'm cutting on the outside of the line. That means the bit is actually running on the outside of the line. The top part of the bit is running on the outside of the line. You know, so that means my bit's not even, you know, it's cutting. It's the right, you know, the left or right side of the bit, depending on if you're climber, conventional cutting. But anyway, I'm on the outside of the line. That means the edge of my bit, the widest diameter, is cutting on that outside edge. My allowance offset is how far that bit is permitted to cut in. You know, when it's cutting around, I want to be on the outside of the line, but allowing it to go past the line by this much, negative when you're going over the line. And so that I'm basically breaking this 5/16 inch depth of cut into 3 separate passes on the edge, not, you know, and all that. Okay. Now, I'm going to do one pass with this allowance. So I'm basically going to calculate this toolpath. Okay. I'm going to come back in here and I'm going to duplicate this toolpath. Duplicate this toolpath. I'm going to open up that duplicate and I'm now going to multiply this by 2. And I'm going to calculate this toolpath. And I'm going to duplicate. And then I'm going to multiply this, or I'm going to add. I don't need to multiply that. I'm going to add, or I'm just actually going to make it my third cut, which is negative 0.3125. And calculate. So now, oh, Jesus, Laney. Hold on a second. Let's try that again. Let's go back up here to number 1. Make sure you got your right vector selected. Goopo, Laney. Let's come in here. All right, with the correct vector selected this time, we're going to calculate that one more time. Okay. And then we're going to come down here to number 2. With the correct vector selected, we're going to calculate that one more time. And we're going to come down here to number 2. And we're going to calculate that one more time. All right. So if we were to go into a solid view, currently right now, and let me uncheck these toolpaths and everything. All right. You will see that my bit will be leading in. And it's going to come and cut past the line by this much. It's going to be removing that small amount of material, about a little over 1/8 of an inch material. And it's going to come around and it's going to overcut by 1/4 of an inch. And then it's going to lead out before it raises up. Okay. My second pass is going to come in, same place, going to come around. And this time it's cutting a little bit deeper. And my third pass is going to come in. It's going to come around all the way to its final cut depth. And then it's going to lead out. Now notice the lead in and lead out is a little different than before. Make sure I didn't change anything. Yeah, I'm good. So it changed the lead in a little bit. But now I want you to take a close look at this meat right here, right? If my board were a big board, right? Big board, right? Say I had a big board on the table, I would have to make some darn clearance, or at least do a profile cut to cut this part out before I did the edge forming. You understand what I mean? That's a good chunk of change right there. You know, it's an inch and a quarter of meat right there. And if this was getting cut, if it was a box where I was doing multiples out of one board, I better darn well have some waste wood removed before I try to plunge this bit into it, because it's going to come down and plunge to its full depth, lead into the cut, come around, and then lead out, you know. And in this case, my area here where it's leading and leading out is open air. There's no board there. My board is here, you know, so this is all open air. So I'm not worrying about that. But if this was a bigger board cutting multiple parts out and I wanted to do an edge profile on those parts type of thing, you better think about how you're going to clamp that and everything. In my case, my board needs to be clamped solid, and it also needs to be elevated a little bit, because my bit is going to go below that 1.5 inches by a 1/16 of an inch. So it's going to go a 1/16 of an inch below, you know, which is about, you know, half of the bottom of the bit here and everything. So all these things come into play. All these things have to be considered. All these things need to be looked at before you do your project in order to, one, perform the project safely, right? You know, make sure you're doing what you need to do, and make sure that, you know, if I have a bit that's not plungeable and I'm going to try to pierce it through a block of wood and then lead into my cut, not going to happen. Not going to happen at all. If I do have a plungeable bit, right? Let's say I have a big 1.25 inch plungeable bit that can be plunged. That thing is going to plunge in and bore a hole in my wood 1.5 inches deep. And then it's going to remove a massive amount of material before it gets to the edge of that board. And it's going to be removing a massive amount of material all the way around before it leads out. Not going to happen. Not going to happen. You're going to tear something up. It's just going to be, because there's no passes. It's going to the full depth. It's not taking 1/8 of an inch, 1/8 of an inch, you know, all that stuff. You know, it's going full depth because we're getting the full profile all the way around. All these things you have to, when you're creating a project, it's nice to be able to just create a project without having to really think about it. You know, hey, I got this design, gonna carve it and what have you. But projects like this, even though this is a small project, there's a lot of thought that has to go into exactly how this is going to be doing, especially if I'm going to try something as fancy as an edge profile. Got a lot of thinking to do, not just in the design side and how I'm creating my toolpaths, but in how I'm going to clamp it and all of that stuff. There's a lot of factors that are taking place, and I'm just trying to nail it home for you guys. I don't mean to repeat myself, but that's it. So those are going to be my toolpaths, and unfortunately, if I reset this preview and I preview all the toolpaths, we're not going to get to see the edge cut, and I wish we could. You know, wish we could see that. Let's see here. Let's go back and answer some questions while this is pocketing out and all that stuff. Let's see. Jeff says, how will you be able to keep a bit from taking a 5/16 offset inch in one pass? We just covered that, Jeff. So hopefully that answered you. We just went through that, how I'm doing it by dividing the offset allowance into 3 separate passes. Let's see here. This cut, I think we would all like to see you do on your CNC. Absolutely. We can show that. It probably won't be live, but I can probably make a video of it. The only reason why we wouldn't be live is because I had some really nice antennas that sent a really strong internet signal out to my shop. When I moved, I took them with me. And when I moved back, I left them. So I got to buy a new set. So I would be able to record it, but it wouldn't be a live preview, but I would be able to record it so you could see the actual cut take place. You could see the whole performance and all that, which is not a problem. Now, the challenge is I've got to find the appropriate bit for the size I want. This bit, by the way, the bit that I'm working off of is Eagle America's box side bit, box side edge forming bit. And we'll take a look at that real quick. Okay. And let's see here. It is tool number 1402, which is that bit right there. Okay. Now, of course, like I said, it's not a plungeable bit. You know, there's a bearing on it, so it doesn't plunge. Now, of course, I will be removing the screw and removing the bearing. I don't need the bearing on there and everything when I'm cutting with it, but it's not a plungeable bit, so it doesn't plunge. You know what I mean? You know what I mean? Okay. And I have to, you know, that 1/16 of an inch that I'm, you know, coming down and everything, I got to measure the bearing and the screw. If I were going to use this bit, I have to make sure, because when I touch the bit off, it's going to be touching off 0 to that, right? Well, this is the bottom of the bit up here. So most likely I'll end up modifying this bit, which I do not recommend you guys doing. Just talking about what I would do, I'd probably end up taking the bearing off and grinding the bottom flush and getting rid of the post because I'll never use the bearing unless I use it in my router table. You know, I might keep it for that because it is a $72 bit. You know, so I might not modify it too much, and I do not recommend modifying bits, you know, so I'll probably do a little bit of research and find a nice profile bit that doesn't have a bearing. But this is the bit that I'm working with here. It's a box edge bit. Okie dokie. Okie dokie. All right. So unfortunately we can't see the edge profile in the Vectric software, but that's that. So we can go from there. Let's see here. Ronnie says, yes, it would be neat to see. And last one, Andy pops up here, says, if you route these all in the same direction, aren't you risking tear out at the end grain? So basically, Andy's saying, you know, if you're routing these in the same direction, aren't you risk, you know, tearing out the end grain and everything, especially with the bit coming around and, you know, exiting, you know, on this corner right at the end grain, you know, it could have a possibility of tearing out there. So on the lead in and lead out, I can choose where I want to lead in and lead out. I can change that, and we may do that. Also, you typically want to route your edges first, and then when you come back, you know, and do your sides and all, it will clean up if there's any tear out here as you're doing your edge forming and stuff. Just like if you were doing it on a router table, you do your end edges first, round, end edge, round. You always start on an end edge, you know, end grain. And so in my case, we may end up moving the bit to move over here. And if there is any tear out, it'll get removed and cleaned up in the last, you know, the last passes and all. As far as going in the same direction, man, you can mix it up if you want, and everything. You can change directions and all. You have, I believe, in the toolpath, you have the ability. Let's see here. Up here in the separate last pass, you have the ability to reverse direction. So on the last pass, you have the ability to reverse the direction. Sure enough, and all. So, but no, I'll end up cutting the same direction. But one of the things I will do with looking at that and everything is I will change my lead in, lead out location. So let's go back into here and let's go into node editing. My start point's in that corner. That's why it's starting over there. So what I'm going to do is I'm going to right click on this point here and insert a point. And then I'm going to make that my start point right there. And I'm going to come back in here and select that and recalculate. Come on, ye faithful. Let's close that. Number 2. Calculate. And number 3. Calculate. Okay. Now for me in this job here, my profile, edge profile toolpaths are not finalized because I'm not dead set on if I'm using this bit or not. But they are created for the class purpose and everything. And it'll all be decided if I want to use this bit or not. And I did order this bit. Hopefully it'll be in a couple of days. But I'm also going to take a look at other bits online and see if I can see something else that might be better fitting. You know, maybe something that's 1.5 inches diameter so I get the whole profile, or maybe a combination of 2 different bits, you know, maybe a box core bit and some kind of other edge forming bit, you know, beading bit or something. I don't know. I'll figure that out in a day or 2. Okay. All right. Enough about this. It's 8:54. It's 9 o'clock and we haven't even gotten anywhere near the box lid. So we need to jump on that. How many of you are going to stick with me through the box lid, or do we need to break this up? Because we ran quite long on that one, but I really needed to emphasize a lot of stuff to you because of that edge forming and all. You're going to stick with me, say yay or nay, or want me to keep going, or do you want to continue another day? All right. Let's turn that off. Okay. All right. So let's take a look at my the vectors I'm going to be using, and let's go ahead and create my. Let me borrow this. Now I'm being lazy. Copy to layer, class layer. I don't know why I did that. But anyway, all right, let's turn off the original vectors. We don't need those on right now. And let's turn on the class layer. All right, let's come up here and look at this. Basically, I have 2 vectors. Okay, I'm going to go ahead and show you the photos that I pulled, that I traced them off of and everything. Let's go ahead and not import bitmap or vector. We're going to import a bitmap. And let me remember where they are. Yeah. All right. So the first image that I traced was a very poor quality, not a great quality image at all. But this is just a simple black and white image that I traced to create the dragon here. Traceable vectors. You can also see there's a lot of pixelation, you know, and things in there. It didn't trace very well, but we're still going to use it. You know, there's some pixels in there. There's some overlaps here, you know, things like that. So that was the first image, and basically select on the image, went over to the trace bitmap tool, black and white. Let's go down and turn the fading off. I'm going to slide this all the way over till I get the best representation simply default corner fit, default noise. Maybe I should turn the noise up a little bit. Preview. Okay. That's all I did. So I got that those vectors and all. Okay. So that was the first image. The second image I used was just a very simple decorative little watercoloring type graphic, you know, for watercoloring. Did the same thing, trace that one. That gave me these two vectors here. Okay. All right. So first one's first. Let's go ahead and get this one on the board. I'm going to hit F9 to get it on the center of the screen. Okay. And I'm going to go ahead and just for right now, I'm going to move this up, keeping it centered left and right. So I'm not centered. Notice I'm off. So let me get it centered again. Use the alignment tool, left to right, get it centered. And I'm going to close the alignment tool. I'm going to double click on it to put it in transform mode. I'm going to hold down my control key and I'm going to drag down a copy. Okay. Now I hit, let's try that again. Don't hold down the letter C thinking it's the control key. Yeah, hold down the control key and pull it. You son of a gun. Okay. All right. Once again, let's get them centered on the board, left to right. Get this one centered, left to right. All right. Now, this particular image is called a repeating pattern image. Basically means that I can put this image over on the right side, the left side, the top, the bottom, and the pattern repeats itself. If I bring these two images together, you will see that they repeat themselves, you know, and they kind of match up. Well, I'm going to hold down my control key and I'm going to use my down arrow key, not my left arrow key. Let me get it centered again. I'm going to use my down arrow key. Center, center, close that tool. Hold my control key down. I'm going to use my down arrow key. And you'll notice that, you know, they line up, right? And if I go down, you know, like when those edges come together, they line up, you know, right? Because it's a continuation of itself and all. So what my goal is to make sure that all of my lines are at least overlapping a very small amount. They don't have to be too big, but make sure they're all overlapping, and they will on a repeating pattern. So all I have to do now is ungroup. That's this button over here, or the letter U on your keyboard. We're going to ungroup this one. We're going to select this one and ungroup that one. Ungroup. And I'm going to select this vector and this vector because that's the only vectors that are overlapping here, these areas here. And I'm simply going to weld them together to create one continuous pattern. Okay. Now I'm going to take this entire pattern and I'm going to center it on the board there. And I'm going to come in here to the edge of my board, and I should have a vector on the edge of my board, which I don't. So I'm going to draw a rectangle. Rectangle. This rectangle is going to be 2 3/8 by 3.5. I'm going to center that onto my board. And that's going to take up the whole edge here. Now, while it's selected, while that edge border is selected, I'm going to go into the offset tool. And I'm going to come in here and I'm going to offset inward to however far I want to offset for my my center area, you know, what I want my dragon to be in and stuff and all that, you know, the area that my design, my pattern is going to be in. And in this case, if I turn off the class layer for a moment and turn on the original vectors, you'll notice that from the outer edge to the inner edge here, I have a distance, a measurement distance, an offset distance, if you will, of, actually, I'm going to go to here. About, you know, 0.4, you know, there was no rhyme or reason, just how big I wanted my, you know, what I wanted the size of the box to be and everything. So about 0.4 roughly, you know, that was kind of the number that I picked, you know. Let's go back into the class layer. Okay. And so on that border, I'm just going to offset inward, and we'll stay kind of the same, 0.4, not 4 inches, 0.4. And I want to create sharp offset corners. I want sharp corners when it creates this. I want to select the new, and I'm going to click offset. Now, this is my trimming border. It's not going to be my final, you know, size, because I'm going to we're going to offset this one more time. But this is what I'm going to trim this pattern to. So I'm going to select this pattern in its entirety. Let me delete this rectangle here. I'm going to select this pattern in its entirety, the whole thing. I'm going to deselect by holding the shift key. I'm going to deselect the outside border, and I'm also going to deselect the inside trim boundary that I just created, because I want to reselect this trim boundary last. If I select it last, then that becomes, when I use my trim tool, that becomes the boundary. The last object I select is the boundary. And this will allow me to clear outside of the boundary or inside of the boundary. And in this case, I want to clear outside of the boundary. So when I clear, it's going to remove everything but that area within that boundary. And it's going to redraw all the lines closing off the vectors and everything. Now, I do not want the lines overlapping like this, so I'm going to take my trim boundary and I'm just going to offset it outward a small amount. Okay, I'm going to probably go 20 thousandths of an inch, 0.02. Create sharp corners, select new. Delete the original. I don't need this one anymore. I'm just going to move it away. So it's going to create this nice little boundary around here. Okay. All right. So that's the vector. Now we're ready to create the model. Okay. So we're going to move into the modeling tabs. And we're going to use the create shape tool from vector outlines. I'm going to go ahead and I'm going to create a new level here, insert a new level, and this is going to be the class level. We'll rename it. This will be where we're class level. And I'm going to come in here and turn off the original components. So that way we're working in the class level. And these are the originals of the model I created yesterday. All right. So in the create shape tool from vector outlines, I'm going to first select all of the vectors here. And I'm going to create a flat profile to a certain thickness. Now, in the case of let's call it the ornate pattern, the ornate pattern. I'm going to go ahead and just go with a 50 thousandths of an inch, 0.05, 50 thousandths of an inch. And I'm going to, for right now, I'm going to set it to a merge. And I'm going to, might as well name it. This is going to be my ornate base. Ornate base. And I'm going to go ahead and click apply. Let's split the view here so we can see what's happening. Bear with me a second. My view tools are gone. There they are. Let's split the view here so we can see what's happening here. All right, so flat profile, 0.05, merging it with whatever is going to come after it. I'm going to go ahead and click apply, and that's going to create my foundation. Okay, that's going to create this foundation. And so basically, because this vector was selected at the same time, it's basically going, around. It's going between the lines, skipping, going between the lines, skipping, going between the lines, and it's creating this pattern here. Okay, so this is just going to be my foundation. All right, now I'm going to click on start a new component. That's going to do a grayscale and lock this component in for me. And now I'm just going to select the inside without this outside border. And now I'm just going to create a model between these lines. Now the model that I create between these lines is going to be a curved profile. Curved profile. I'm going to have a 30-degree curve on it. 30-degree curve. And I want that 30-degree curve, when it builds up and everything, I want it to come beyond this base a small amount. I want it to extrude beyond that or past it. So I'm going to give this a little bit more of a base height, but I won't do that until after I click apply and see where I'm at. So it's a merge. I'm not going to limit the height. No limit. I'm going to click apply. I'm going to let it build in that model. Give it a second. It's going to take a second. It's working it. It's working it. There's a lot of little vectors in there. It's building that model on. I don't want to click again because it'll tend to want to freeze up, and it'll cause us to freeze up. Work it, model. Work it, Aspire. Come on now. Okay. Let's look at where we're at. All right. So barely breaking the surface. So I want to give it a little bit more base height. So I'm going to single click on this, and I'm going to use the roller wheel on my mouse to give it a second. I'm going to come over here real quick and click save on this, the bottom base. And I'm going to close this Aspire for a moment. Close some of these windows that I have open. Okay. All right. A few little potholes in there. They'll be removed away. All right, let's go ahead and build this up a little bit. Let's go 0.675. Click apply. Okay. Now, so now I've got, let's create a new component. Close this. All right, so now I end up with this. Now, my walls, this is a very thin ornate design. They're kind of fragile right now. So what I want to do is I've got the foundation, I've got the height that I want, but I need to add a draft to this component. The draft is going to expand out this base a bit to give it some girth at the bottom, you know, give it some meat at the bottom, so it's not going to be so thin and fragile and everything. And this is the results of working with a low resolution. When you're creating a low resolution model, you know, this pixelation and everything, we're gonna have to do some serious smoothing to clean this up afterwards, but hey, it is what it is. So I've got my two components over here and all, and I need to select them. And I'm going to add a draft, create a component visible model for a draft added. Typically, drafts are added like in injection molding and everything. This is a nice little angle so the molds release, you know, the part releases from the mold and all. Same concept and all. Now, for this, I'm going to do a 30-degree draft. And click apply. And what widen these areas out here at the base. Okay. So it gives it that 30-degree angle and it widens it out. So it gives me the meat that I need so it's not so fragile and everything. So now, because the outer component, you know, the base was part of the model that I had selected that I created the draft on, it also created an angle out here. And that's fine for me because there's going to be another model created out here that's going to tie into this and everything. So I'm not worried about that angle. If this was the outer edge of my board, I might not want that angle, that 30-degree angle in here, and I might deselect that. But I got the draft, went into my model. Okay. So for that, this part of the component, it's done. Finished. Okay. So now I'm going to go ahead and for right now, I'm going to turn off these two models here at the bottom because notice right here it says model with 30-degree draft. Basically, it took these two components and it recreated a new component with the draft. I don't need the two originals left on. I have the model here. This is the new model with the 30-degree draft. Okay, so I don't need these any longer. I can actually delete them out, but I like keeping my originals intact in case I want to go back and change something. I'm going to go ahead for right now, and I'm going to turn this model off to hide everything. And I'm going to go ahead and move this set of vectors, except for this and this. I'm going to go ahead and move this set of vectors to another layer. And I'm going to call it the ornate vectors. And I'll turn them off, let them go away. All right. Second part of this model is we're going to go back into here for a minute. I'm going to go into here to the original vectors. And I'm going to grab my dragon here. I'm going to center that onto the material. Okay, nice, perfect size for me. I like it, so I'm not going to do anything with it. Now, when this dragon was traced, this outside vector was not part of it. That is an offset. So when the original dragon was traced, this was the file. This particular file was selected, and an offset was created outward a distance of, I believe it was 0.01 or 0.02. Let me zoom in here and click offset. So if I pull this right here, just as a reference point, and I hit Control Z, yeah, it was 0.01, 0.01. Okay, so let's delete that again, and let's select this whole thing, and offset outward 0.01. There we go. Okay, now I have select new here because all I care about is the outside profile. So I'm going to turn this, hold down my shift key and turn this outside profile off, and everything else is still selected that it just created with that offset. I don't want that. So I'm going to hit the delete key on my keyboard and delete it. I also don't want this guy right here. I'm going to ungroup this for a minute and get rid of him. Everything, and this guy on the hand, get rid of him. These are pixelation of a low quality image, and those guys, all these little, as long as they're not crossing, overlapping, not crossing, but overlapping one another, I don't necessarily need them. I'll leave those. I don't necessarily need those two. This is all pixels. These are all scrap. Now I could go ahead and redraw this if I wanted to. You know, I could redraw this curve in here. This curve is basically, it was a low quality picture, so the curve didn't quite trace well. So it created these, you know, it grabbed whatever pixels it could when it traced the original image. And I'm fine with leaving that there. If I wasn't, I could come in here and I got two choices. One, click here and pull that over to there. Click here and here. Pull that over to there. Come in and delete. These, and select these two and join them together as one closed vector and simply redraw it, right? You know, if I wanted to take that time. Okay. All right. So anyway, I got my model here. I got my offset line and everything. I'm good to go to start creating this model. We're going to go back into the Create Shape tool. And this first part of this model is going to be created with everything selected, even the outside profile. Okay. And this is going to be once again, it's going to be a flat profile on this one. And it's going to have a depth of a base height. I'm going to go 0.06 799 or 08. I mean, it really didn't matter. But I liked the way this looked. And I'm going to add this as a merge. And I'm going to click apply, and we'll split the view here. Okay. So that's going to create the outline area of the dragon. I'm going to create the outline area. Now I'm going to create a new component. And I'm going to come in here and select just the inside vectors without this outside boundary on. And I'm also going to create that at about, this is going to be a curved profile, slightly curved profile. And it's going to have a 04. Actually, I'm sorry. It's going to be the same thing. I'm just going to go 08 and click apply. Okay. And now this is where I decide what I want my shape height. If I want more shape height than this, you know, if I want a little bit more detail in the things and everything on this shape height, this, you know, this curve and all. So I'm actually, let me show you if we build it up just a little bit more. Let's go to 0.09 and click apply. You know, it's going to start building this up a little bit more. Okay. And all. And I don't want to go too high. You know, I could, if I wanted more of an angle, I could add, you know, a little bit more roundness, if you will. I could go 40% or 35% or what have you. And let that this will kind of start puffing up a little bit more. You know, it just depends on what you want. Okay. In my case, I want this to be at 30%. And we'll go 0.909 is fine. Let's see here. Let me see what 0.1 is. Okay. So we'll go 0.1 on that. All right. So now we're going to go ahead and click on Start a New Component. Actually, we can go ahead and close this tool because we're done with it. And now we need to come back in, and I want to do some work to the dragon. First of all, I want to take and add a little bit of a draft to him as well. Not much, because I'm going to be adding another draft to him later, but a small draft to him, and maybe do a little bit of edge smoothing. And we're going to do some more smoothing when it's all finalized as well. But let's go ahead and add a small, let's select both of the components that make up the dragon. And on the dragon's draft, I'm going to start out with a 21-degree draft for the first part. And these are just numbers that I picked that I thought looked good. And yeah, Andy says it would be very cool to have picture files for the class in advance and everything. Yeah, if I could figure out a way to get them out to people and stuff, I'll work on stuff like that, Andy. Okay. So I'm adding that draft, and that's basically putting this nice angle on this, kind of filling in this and giving me some definition. And even for a crappy photo, it's not a bad looking model. And when you add it to the other components and everything, it really creates a neat looking little model, just for something, for what it is, for what it is. Not a whole lot of detail in it, but, for what it is, it's not too shabby. All right. So we've got that. Let's go ahead and close that tool. Now, once again, we've got the model created with the 21-degree draft. So I don't need the two originals on any longer. Okay, I've already got the model with the draft. So what I'm going to do now is I'm going to come down here and turn on my other model with the draft, which is the ornate piece, right? To put those two together. Now, let's zoom in and let's take a look at some things. Okay, I would like the top part of this ridge, because I'm going to add another draft to this, but I would like the top part of this ridge to line up with the top part of the ornate pattern. Okay, I'd like that top part of that ridge to line up with the top part of the ornate pattern. I want to bring, I want to bring the base height of this model down a little bit to, accommodate that and all. So if I come into my dragon model, when I select it, it'll be red here. If I go into the properties, I can begin to adjust the base height a little bit to bring it down. And I'm going to just drop it down a little bit to start off with. Okay. And that little bit did what I needed to do. It brought that kind of together. I want to make sure, I want to come in here and I'm going to really, really look at my model closely. And let's turn off, let's deselect everything. So it's all, I want to look really closely and make sure that, I'm not compromising, anything by doing that and all. And everything's fine. Now, let's take a close look at this. My pattern is still showing up in between my dragon and everything. And I don't want that. I don't want the pattern going underneath, like between the fingers and stuff like that. I don't want that at all. So what I'm going to do is I'm going to come into here and I'm going to select my model here of the ornate pattern. And I'm going to come up here and hold down my shift key and select the outside boundary. The outside boundary of the dragon. So I've got this model selected and the outside boundary of the dragon selected. And if I come over to these two tools here, I have the option to clear everything out of the selected component from within the selected vector or outside of the selected vector. I'm going to use inside the selected vector. I want to clear all the component inside the selected vector. So when I do that, it's going to remove that material away from inside. And let's turn off this model so you can see what I mean. Okay. It removed all of that material around the dragon away. Okay. I didn't need that model underneath the dragon and all, so it removed it. So I can put my dragon back in there. Okay. Now, on this model here, I haven't done any smoothing or anything yet. Before I do, I'm going to add another draft to these parts. And it's just going to be on the dragon itself, not the base component. So I'm going to add another draft to this. And this time the draft is going to be a 30-degree angle. And let's zoom in here so you can see, kind of get an idea what happens when that is created. give it a second to run through. I had the darn dragon selected when I think I had the dragon. And basically that's going to blend in a little more to that orange edges. And when I do, it'll really clean this up nicely. Everything. Okay. So it's now going to blend that dragon in a little bit better into these components and all. And, you know, really make everything. And let me go ahead and turn on Toolpath, or I'm sorry, View, shadow shading. Yeah. Okay. So that's going to give me, you know, a nice little model. Now we're going to come in and we're going to do some smoothing to really smooth this out a bit. And let's get into full view here. We don't need to see that. Let's go into full view here on the dragon. And now we're going to take, once again, I don't need this model still selected. I've got the new model with the 30-degree draft on there, so we can go ahead and turn that off. Okay. Now I've got my base component, my dragon component. I can go ahead and apply a smoothing toolpath. Sorry. Don't hold your shift key down when you're selecting two separate items. There we go. I'm going to go ahead and apply a smoothing toolpath, and it's going to ask me to bake the components together as one model before it smooths them out. I'm going to go ahead and click OK. I've still got my originals intact and everything, except for the draft and all. I'll just have to redraft them. But I can go ahead and model, and that's fine. Okay, so now I can take my slide bar here and I can bring it over, and I'm going to just do a small amount of smoothing. Okay, let's zoom in and let's kind of get down here and watch here as I slide this bar over. These edges and all. And I don't want, if I overkill it, and I'm just going to slide this over to the middle here. You know, if I overkill it, then, you know, I'm going to lose a lot of detail, you know, as you can see and stuff. And I don't want that. I just want a nice amount of smoothing around the edges. So I'm going to probably be maybe, I guess that would be like a quarter or a third or something. You know, I still want my edges defined and everything, but I just want them smoothed out. So before, this is no smoothing right here. You know, all my edges and everything. And after. Now, there is a box here that says preserve transparency. You know, in some areas and all, there's transparency and stuff. And if I check this box, it's going to change how my smoothing is affected and everything. And you see what happens here and all. And now I've got, you know, my quarter inch. I've got nice edge definition still on everything, but it's nice and smooth. So from those two, very poor, and click OK to confirm everything. From those two, not the greatest pictures in the world. So far, it's a not a bad looking model. Okay, we're almost done. All right, now that's my centerpiece. That's my centerpiece. So the last thing that I need to do is create a shape. You see how that 30-degree draft, you see here's my vector here, but the 30-degree draft put the model out here. That's great for me because when I create the frame model around it, it's going to blend perfectly in with this. So we'll go ahead and audio check. Mike says audio beginning to mess up, and that's because while it was calculating that smoothing and stuff, it was acting up, Mike, most likely. But I'm going to go ahead and select this vector here and this vector here, and I'm going to go back into my Create Shape tool. This is going to be a flat profile. I'm just really building up this frame around here. And the frame itself, the height of this window here was 0.05. Let's go ahead and go with 0.05. Let me split the view again. I'm going to go 0.05 to start with. Merge. And click Apply. And what I want, all right, so 0.05 is nice and even. I need to go higher. I want to go up to the height of here. So that's going to be about 0.0679. So let's go 0.07 and click Apply. Moving my mouse over to a part of the model. It says it down at the bottom, your Z numbers and all. And what I'm looking for is this, a nice little lip to create basically essentially like a little frame around. I don't want it too high. I don't need it, you know, too high and all, but I just want it to be where it really stands out, the nice little edge there. Okay. And that's going to give me my panel. Now, when I'm machining this and everything, there's no need to machine the flat area. That's just a waste of time for your ball nose bit to machining the flat area. We can create a pocket toolpath to flatten this out to where it needs to be. We're going to use this inside vector here when we're machining, so it machines inside this vector only. It's only doing this part of the model. There's no need for that bit to be doing this, because on this here, I'm most likely going to be using a 32nd inch bit to get the best detail possible that I can get out of it. And I don't want that little 32nd inch bit trying to flatten out all this stuff up here. So I won't even be milling this as part of the 3D model. This will be a pocket cut. You'll see that in just a moment. Okay, so now I've created my component. We can go ahead and close this tool. And we can go ahead and maximize this up. Let's see here. And we're ready to, on this side at least, we're ready to create some toolpaths, but not quite yet. And the reason being is, when I created this component, no, I'm sorry. I want to do a, let me see here. I want a nice little rounded over edge here. I want the top of the board to have a nice little round over. You know, nice little round over. So I'm going to do this outside border just a little bit different. Bear with me, guys. What I'm going to do is I'm going to take and I'm going to offset. Because if I do a round over the way I'm about to, it's going to create a round over on the outside and the inside here. And I don't want this to have a round over on the inside. I want a nice square lip. So what I'm going to do is I'm going to offset. I'm going to create an offset inward, just a certain amount. Let's see here. Let's go a 1/4 of an inch inward. Square corners is fine. Offset. Okay. And then I'm going to take this offset and go back outward. 1/16 of an inch. I'm going to create these two little vectors right here. What this is going to do is I'm going to come back into my modeling tool, and I'm going to delete that last model that I created. And the first one I'm going to do is I'm going to create between here and here. Hold down your control key. I'm going to create a component, a flat component or a curved profile component with a 90-degree angle, my same base height of 0.07, but I'm going to limit the height. So that means at a certain height that I limit to, it's going to flatten it out and everything. And it's what that's going to end up doing is that's a way to create roundovers on your edges and things. So I'm going to limit this to 0.03125, limit the height. When I click apply, and I'm going to do a merge. When I click apply, it should give me a rounded over edge on the component. Basically, it's trying to do a 90-degree dome. Like if I did no limit on that, I'm getting a 90-degree dome, right? Well, when I limit the height to whatever limit, when it reaches that height out at that height, and that's what gives me these rounded over edges. But you see it does both edges, right? And I don't want the inside edges to be round. I want a nice crisp square edge, up here. So by creating the two separate vectors, those little offsets and all, I was able to create the rounded over edges here, right? And now I can start a new component, and I can select this outside vector here and this vector. Hold down your control key or your shift key. And I can create my flat profile with that 0.07 and merge it. And what it's going to do, it's going to create that frame back out to here, and it's going to cover this area here. And of course, I got to merge, boy, merge. Oh, I got to give it different. That's fine. Hold on a second. Click apply. Remember, my bubble is going up an additional 3/16 of an inch and then flattening out, right? So I got to lower this by that 3/16. So I'm going to close this. And in that first component that I made, on the properties tool, I'm just going to lower the base height, the meat underneath. I'm going to lower that down by a little bit. Ooh, not that much. This is going to be a pain in the butt. Hold on a second. 0.07, 0.0750. So I need to lower it by 0.0750. If I take this number, subtract that number. Give me a second. Got to do my math. Where's my calculator? Isn't that terrible that I got to use a calculator for that? .1013 minus 0.0263 equals 0.075, which is what I got there. And this is 0.070. So I need to remove an additional 5 thousandths of an inch. So, and I can remove it from either one. Let's go with this one, 0.0263 plus 0.005 equals 0.0313. 0.0313. And the green just is showing that the model is consumed by another model. That's what that is. And when I click off of it, now I should have a smooth surface there with rounded over edges. Okay, so just so you know what was going on there, my shape height, that 3/16 of an inch where it flattens out, that's the shape height. That's that curve, even the flat top up here. The base height is the straight meat underneath. The total of the shape height plus the base height is my total height, 0.070. And so this was a little bit higher than this over here. And so I had to find out what that difference was, which was, it was 5/1000ths of an inch, 0.005. And I could subtract that from either one. I didn't want to subtract it from my base height because I want my nice round over, you know. So I subtract it from the base height, the meat underneath, to bring it down to that level. And then with it set as a merge, it'll blend together. Okay. So that's what we did there. All right. So there's my lid. All right. Now, we're going to get to that. We're about to create the Mike, where Mike asked the question, what is the time for milling the top of the lid? We're going to get to that. I'm about to create the toolpaths, but let me real quick create my magnet holes and stuff. Okay. Just real quick. Okay, let's go ahead and close and let's get out of this. And so we've got that. Now I'm going to take this here. My selected vectors there, and I'm going to move that. Except for this one right there. I'm going to move those two and the dragon. I'm going to move those to a new layer, and I'm going to call that my dragon and I know the two borders weren't part of the dragon modeling vectors, but it's fine. I'm just wanting to move them off the board for a moment. Okay, so for right now, I can go ahead and turn off all the components for the moment. And I got a blank slate here because I need to get my magnet vectors, my magnets in there. And in order to do that, I'm going to go back in and open up my base file for a minute. And I'm going to steal the vectors from the base file for the two holes, the placement of the two holes. Because I know they were 0.3 and 0.3, but I'm going to steal this. Because that's my outside border, that 2 3/8 by 3.5. And this is where my vectors are from that. So I'm going to steal that. I don't need this. When I say steal, I'm just going to click copy and paste. And then I'm going to take those vectors and center them. And that tells me where my two placement holes are. Now these holes go on the other side. So I'm just going to select these and that extra vector there, and I'm going to move them to the other side. That's my magnet holes. Okay. All right. With that being done, I can go ahead now, turn my layers back on, my level for my model and everything. And I can go ahead and get, oops, dadgummit. Control key, not shift key. I can go ahead and with those on, look at my 3D view, make sure I got everything. Everything's everything. Good. All right. So now I'm ready to create my toolpaths. So that's done. That's done. Oh, we got to close Mike's question. Sorry about that. Wayne Henniker, no, the roundover is not done with a roundover bit. The roundover is done as part of the model carving. If I had a roundover bit that small, if I had a roundover bit that small, which is a 30-second roundover, then I would use a roundover bit. But the smallest roundover bit I have is an 1/8 inch, so it's part of the model. And you'll see how we'll create the vectors so it does that roundover everything in just a moment. All right. Let's go ahead and let's get out of the back into the 2D view here. Got my model vectors and everything there. All right. Let's come in here and sorry, guys, I was about to sneeze and I had to pause for a minute. Okay. So the model, the 3D model here, this is going to be the boundary for carving that 3D model in that area. And let me show you how to turn a model on. If I select this model, I can right click and go into the object properties after I turn off these vectors here. I can right click and you can, I got to bake it together. Bear with me a second. Modeling. Let's go ahead and, oh, you son of a gun. I keep hitting my shift key. This one, and this one. I'm going to go ahead and bake them together. Okay. And on that baked model, I can, if I'm, it's, how it grays out when it's not selected on, you only see it when it's selected on. If I right click on it here, I can go to the object properties and I can slide the fading off. So it's permanently like this so I can see it. You know what I mean? Know what I mean, man? Okay, so just this inside area here, we're going to be milling, 3D modeling, and also this little round over outside edge. We're going to let the bit come over and do that. And so I have a vector here, but that vector is not going to be used other than a profile cut to cut the part out. I need to create 2 additional vectors. So I'm going to use my offset tool and I'm going to offset outward. 1/16 of an inch is fine. And that's going to be the machining vector for when I'm, that's going to be one of the vectors when I'm using to create my pocket tool path. I want that bit going over that edge and everything when it pockets this out and flattens this area out here. But I'm also going to have a tool path. I'm going to go inward from this guy by 1/16 of an inch, not outward again, inward by 1/16 of an inch. And these 2 vectors are going to be the machining vectors to allow my modeling to do the roundover. So it just stays in this area here when it's coming around. That way it's not, I'm not wasting a lot of time on these flat areas here. So what I mean by that is first toolpath is, or first thing I'm going to do is go into my material setup. And let's close these tools over here and let's zoom into full view there. Go into material setup and I'm going to look at my model. My model currently right now is sitting at the bottom of my board. We don't want that. Needs to be up here at the top. Okay. All right. My model Z-plane, meaning the bottom of my model, okay, is 0.2736. Okay, my model Z-plane is 0.2736. And for me now, I'm working off the machine bed. If I change that to the material surface, just for shits and giggles, so you can see what's in the machine material surface and everything, my actual model Z plane from the top of my board, which is now Z0, is 0.1014, which is the model thickness. Okay. But I'm working off the machine bed. And it shows my model Z plane now as 0.2736. Well, for me, because I work off the machine bed, I have to do a little bit of math. 0.375 minus 0.2736 equals 0.1014. My model Z plane. Okay, so that's how when I mill this pocket down to this flat area, my cut depth is going to be 0.1014. Okay. If I were working off the material surface as 0, then it would just show me the 0.1014 here. But I'm working from the bottom of the board. So my bit, this is 0, my waste board. The top of my board is considered 3/8 of an inch. My model plane, the bottom of the model, is the 3/8 of an inch minus this 2.736 right here, this meat here, which equals 0.1014. I don't want that to confuse you, but when you're working off the bottom material, there's sometimes where you have to do a little bit of math to get your cut depths and stuff. All right, 0.01014. So let's click OK. And let's go ahead and create our toolpath. So my pocket toolpath is going to be from this vector to this vector. It's going to be a pocket cut. It's going to cut point. What the hell did I just say? Damn it. Remember your numbers, guys and girls. Remember your numbers. 0.1014. 1014. Let me write that down. 1014. Okay. Okay, pocket toolpath. 0.1014. 1/4 inch end mill is fine. The offset is fine. I don't necessarily want a raster, in here. I'll let it go ahead and go around and around and around. That's fine. So I'll use it as an offset. And this is going to be my flat area pocket. Calculate. Okay. What that's going to do is that's going to mill that area flat. Okay. That's going to bring me to my final depth right here in this area. Okay. My final depth in this area. Instead of my little 32nd inch bit trying to flatten all this out, my pocket bit just did it for me in 1 minute, 27 seconds. Okay. So now I'm going to select this vector, and this vector, and I'm going to create my 3D rough and 3D finish. You may need a rough, you may not need a rough, depending on how thick your model is and all. You could just go straight with a 3D finish. I'll do a rough cut. 3D rough cut. I'll use my 1/4 inch end mill that I just used to pocket this out with and everything. I'll jump right into that, and I'm going to use the selected vectors as the boundary. Okay. Selected vectors as the boundary. And I'm going to go ahead and Z-level raster. I'll do a profile. It'll go around and do a final profile last. And I want to go along the x-axis. And in this case, I'd actually like to go along the y-axis. It'll be a little bit quicker for me. So along the y and calculate. This is just doing the rough cut, hogging away any waste material. The model being 0.104, I mean, it's less than an eighth of an inch. I technically don't need a 3D rough cut for this. My ball nose bit can do it all, but I will be using a 32nd inch ball nose bit, which has a 64-inch radius on it. So it's going to be a very fine detail bit because I wanted to get into all these little crooks and crevices and all these little ribs up the dragon's body and everything. And I want that little bit to be able to get in there the best it can. There's going to be some tight areas where it can't fit, but still. Okay, now, no toolpath was created. It's saying that the pass depth for the tool, it doesn't exceed the depth of the model. It's saying, hey, you do not need a roughing toolpath. The model's not thick enough for the pass depth of the tool, you know? So check the pass depth of the tool. Check that the pass depth of the tool does not exceed the depth of the model being machined. What that means is either I don't need to do a rough cut, or I simply need to come in to edit my tool and reduce the pass depth. So if I came in here and reduced the pass depth, and calculated this, if I'm die hard that I want to do a rough cut, right? But it's such a small, the model that's not very big, it's not very thick and all. This isn't like a 20-inch by 20-inch project, where with the, the half-inch thick model. This model's it's less than an eighth inch in height. Just a nice little detail model for the top of a box, a small box, and add that, 2 3/8 by 3.5. But if I'm diehard that I want to do a rough cut, then I need to reduce my pass depth so that it doesn't exceed the actual depth of the model. And my 1/8 inch pass depth was exceeding the pass depth of the model. So we're almost done, guys. We're going to call it a quits in probably about 20 minutes. We're almost done. I appreciate you sticking with me this long. It's been a long night. Hopefully. All right. So once again, no pass depth created. So basically that means no rough cut. Okay. It says, just so we can read it, check the pass depth for the tool. Check that it does not exceed the depth of the model being machined. And that the tool actually fits inside the model to be selected boundary. The depth of the Z-level pass is controlled by the pass depth value for the tool. Well, one, my rough cut bit will not fit in here. So what that means is I'm going to go ahead and turn these vectors off. Don't need a rough cut in that area. And we'll try it one more time with a reduced pass depth and here, and see if it fits in here. So we'll calculate this one more last time. And if I get that warning a third time, then I'm going straight to a finish cut, no rough cut necessary. Because it's saying that the bit just can't fit in there. There's no point in it. There's not really a lot of material to be roughed away. Now, if this was a half-inch thick model or something, it'd be a whole different story. There'd be waste material that needs to be milled away before your finished bit goes in there, because you may or may not know, and yes, you can use a smaller end mill too. Wayne Henniker asked the question, can you just use a smaller end mill, like an 1/8 inch end mill? Yes, I could. but I don't want to do a bit change on this. You know, I'm already using the 1/4 inch end mill to do the pocket. I want to be able to just transition into the rough cut if there's a rough cut. If not, then I want to transition into my bit. But yes, I could do a 1/8 inch end mill. I could do a bit change. I don't have to be lazy. But the you might not know this, but the finish cut toolpath does not do passes. All right, let's change the bit size like Wayne was asking. Let's see if that does anything for us. 1/8 inch end mill. It goes straight to the final the allowance left on is greater than 20% of the tool diameter. The finish cut goes straight to the final depth of cut. There is no pass steps on a finish cut of a 3D model. It goes straight to the full depth, and it rides that depth, only raising up and down based on the contours or the design of the model. So it doesn't take passes and everything. So where there's a lot of waste, yeah. So no rough cut on this one, guys. It's all finished. Where there is a lot of meat to be removed, remove it, because your bit's going to be plunging. All right, so for this, I do want to raster, and I want to raster 90 degrees along the y-axis with the grain of my wood. So I'm going to go 90 in here. I will be using a 32nd inch tapered ball nose that has a radius of 0.0156, a 64th. And I'm going to be using the selected vectors as the boundary. Once again, I'm going to be selecting these vectors with this. Selected vectors as the boundary, no boundary offset. I would like to actually do a boundary offset. I would like to let it go past the boundary by a 0.03125 is a 32nd. I'm going to go 0.045. I want it to go past the line so it blends in with this flat area. And stuff. Raster back and forth 90 degrees. And the thing about the raster is it's going to raster this little area right here. Boom, 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 you know, until it gets to the long areas. So I think I'm actually going to do 2 separate finish cuts, and I'll save them as one file. I'm going to take and do this one, and I'll do it as an offset toolpath. Round and around she goes. And we'll calculate that. Offset is round and around and around and around. That's going to be a more optimized toolpath for my edge bit here. Okay. Preview the selected toolpath. All right, and let's select this one. Do a 3D finish. Selected vectors. Same, nothing's changing with this. They're going to be saved together as one file, except for cancel that. It's going to be a raster 90 degrees. Calculate. Let that calculate out. If you guys and girls have any questions, now's the time to start putting them in to ask them. Because once this toolpath is finished, we're going to flip this board over, create the toolpath for the magnet holes, and we're going to be done. Now, the one thing that is missing from here The one thing that's missing from here is my alignment pinholes. For this is a two-sided job. I'm flipping it over. So I gotta make one quick change. All right, so let's preview that selected toolpath. Okay, Junior. What's wrong with that picture? Oh, you son of a gun. O3436. You see that Z number at the bottom? 03436. 0.03. I'm sorry. 0.375 minus 0.3436 equals 0.0314. Calculate. All right, let's preview these toolpaths again. Preview all toolpaths. Should have my pocket cut. My round over cut. My model cut. Okay, now the offset allowance for the offset allowance that I gave for the rounded over edges wasn't enough for the bit to be able to be permitted to go past the line enough to be able to get around that edge a little bit. So I just need to quickly make that a little bit bigger. And I'm going to use the size tool, and I'm going to use the percentage box. I'm just going to make it 105%, 105%. And that, I believe that was that first one right there. Let that calculate real quick. Math is a B. Yeah, Mike Smith. Math is a B. Okay. I wish Fetrick would show the edge profile better, or the edges. But got the round over. Let's change this to Canadian maple, and let me Okay. So that's going to be the lid of the box. And the 32nd inch bit, it got in there pretty good. You know, that there's definition in these areas here. So that's good. Plenty of definition around and everything. I'm not sure why it's showing a edge right there. It's not supposed to. I don't know if that's just the thing where Vectric won't show the round overcut very well. I'm not sure, but that's that side. That's that side. Looking at this now, milled a very minimal amount off this piece here. And so I may even reduce this down to a 1/4 inch piece of material. It depends on how thick I want my lid. How thick do I want my lid? You know, if we switch over to me real quick here, I'm basically looking at, you know, a very thin piece. So I may reduce that 3/8 of an inch piece for this project down a bit. Now I do know that my magnets have to be recessed by 1/8 of an inch. So I need at least 1/8 of an inch. And then whatever, you know, this is getting cut down, you know, 0.14, some change. So 3/8, that's not too thick, but maybe a 1/4. I might, or, you know, 0.3 or something. I don't know. I'm going to have to make the lid out of a piece of 3/8 and see if I want to reduce the size of that. But all that being said, that's just preferences and all that stuff. Let's create our toolpaths here. And then I got to go back and make one fix and we're done. We're going to do a pocket toolpath, cutting 1/8 of an inch deep with 1/8 of an inch end mill. And offset, around and around she goes. And this is going to be my lid magnet pockets. 0.125 end mill. Let's calculate that up. Okay, now when I made this this project here, I made it the exact size of what my finished product is going to be. On this project, I can go ahead and I can do a profile cut, a final profile cut to cut it out. So I'm actually going to increase that because I do need to put my alignment holes in there. We had that talk right at the beginning of the class today. So I'm going to go ahead and just go 3.5 by 4. What was it? 2 3/8? Oh, I don't need to go 3.5. What the hell am I thinking? Just 3 inches. Okay. Click OK. Okay. I'm going to take my model and vectors and everything and center them up. Same thing on this side. Center them up. I'm going to create a vector boundary. This is going to be my final profile cut here. Did I give myself enough room for a damn alignment hole? Yeah, that's my final profile cut right there. So yes, I did. Of 1/4 inch diameter hole. We're going to go might need to go a little bit bigger. Yeah, let me go a little bit bigger on my board size. I don't want that him. I use metal alignment pins, not wooden. Let's go 4.5. All right, one more time. Let me select all of that. Center. This, flip this over. Center. Okay, let's get, got one hole here. Ignore this vector. This is not going to do anything for right now. It's fine that this vector runs into this hole and everything at the top because the pins aren't going to be on the top. This is when it's flipped over and there's nothing getting machined near these holes when it gets flipped over. It would help if I hold my control key down when I'm trying to drag a copy. There we go. All right, toolpath. These guys here are going to get copied to the other side, and then I'm going to select them again. This is going to be a drilling operation. It's going to go it's a 3/8 inch board, 0.25. 0.26 because my dowel pins are a 1/2 inch long and they're metal. I'm not going to shave them down. This is going to be a 1/4 inch end mill. And this is my lid board alignment holes. 0.25 end mill. I'm going to flip this over. Select this and this. Drilling operation. This is going to go 0.25. We'll go 0.26. Again, that way I don't bottom out for sure. This is going to be my waste board alignment holes. 0.25 end mill. Now I've just made changes to my board and everything. I need to make sure that in my material setup that my model is still, positioned up top, and everything. I'm actually going to throw a 0.010 of an inch lead above the model, or a little bit of material. So it has to get milled away before it gets flattened out. But that 0.010 of an inch, I need to add that into my pocket cut here. Click OK. Okay. I'm going to click no for right now because I'm going to go to my pocket cut and I need to add 0.010 of an inch. 0.414. Calculate that. Now I'm going to go ahead and recalculate all the tool paths. calculator here because I just made significant changes in my board. Oh, shit. Sorry, guys. You didn't even see what I was doing. Could you see what I was doing? All right. All I did was I changed the size of my board to allow for the alignment holes. I didn't know I had my camera on. Good thing I wasn't picking my nose, right? Huh? Jeez. Just kidding. I didn't see anybody holler at me about that. Yes, Andy. Andy asked a great question while this is calculating. Is it safe to assume the more dense the wood, the better definition you will get your cut? Yes. By far, you're going to get a much more defined and better cut out of, let's say, a piece of walnut than you would a piece of, pine or cedar or poplar or something. Yes, the more dense the wood, definitely the nicer the cut would be, for sure. Yep. And Wayne asked the important question: are we getting the files for this box? No, Wayne, I'm just showing it off, and y'all got to fend for yourself. Yeah, of course. So it'll be in the description of the files. It'll be in the description of the video. I'll clean up the files. I'll organize everything nicely, and then I'll send them off, or I'll post them in the. You'll get there'll be a check back to the video, and you'll see there'll be a download link for the files. I'll clean everything up and just make sure the layers are organized and the toolpath names are nice and organized and all. But never take a toolpath for granted, guys. You get them from me, you get them from John Smith, you get them from anybody. You get them from eBay or whatever. When you get a project and everything, you open that project up, look at the job setup, make sure it meets your needs for your machine and everything. Never take a toolpath for granted. I had a customer call and he said, could you help me out? My toolpath is wanting me to start way off into no man's land and my machine's not that big. Well, he got that project from, online, and the person he got it from, they created it with an offset in the job setup, the XY datum. And all he had to do was simply uncheck and turn off the offset, and it solved the problem. But he was trying to figure out how he was going to run that with that, with it being way off like that. And you set it up for your job, your tables. Okay, so all the toolpaths are successfully recalculated, and I'm going to assume that means all the toolpaths. I'm going to do it again. Okay. Let's see here. Thanks, Andy. Andy was going to say something about my screen and everything, but he's like, you're in the zone. Mike says, earlier, you said you wanted to use a pocket instead of a drilling, and you use a 1/4 inch for the dowel holes and everything. On my alignment pins, Mike, on my alignment pins, I do a drilling operation with my 1/4 inch bit and everything. My hold, I don't have a issue with wallow out to where it would mess with my alignment. But when it comes to the magnets, I want that hole to be tight and precise. I want to have to push those magnets in with that epoxy and everything. I want a nice tight fit. I might even have to give myself a little bit of an allowance so they fit, but they shouldn't. They should go right in. And I don't want any slop on those magnets. I don't want to have to fill it in with, glue and sawdust, to make it look like I didn't make my hole bigger than it needed to be. So I'm going to use a undersized bit with a pocket cut to precisely drill those magnet holes. But on my alignment pins, I always use a 1/4 inch bit to drill with. If I had an issue where I got wallow out and my alignment pins were sloppy and if it's going to throw my design off, bad or something like that, then I would do the undersized bit with a pocket cut for my alignment pin holes as well. But knock on wood, I've never had an issue with it up to this point, and so I'm going to continue to just use the drilling operation until it fails me, and it hasn't so far. But I don't want no chances with the magnets. I want that tight and right. So I'm going to use an undersized bit to pocket out that hole. All right, let's take a look at what we got here. Let's close this up for a second. Wasteboard alignment hole is going to be top of the list for side 2 because that gets cut in the wasteboard, not the project board. So we can unturn that. We can turn that off, and we can go ahead and preview the visible toolpath. So these are going to be my 2 little magnet holes on the lid here. That's it. 2 little magnet holes there. I got one more. I got a profile cut to do too. Don't forget to remind me. I got a profile toolpath to do too. I don't know why I'm previewing toolpaths yet until I do my profile. As a matter of fact, let's go ahead and get her done now. My profile toolpath. That's going to be this guy right here. And let's do a profile cut. All right, so my board is 3/8 of an inch thick currently right now in this job setup. I'm going to divide that by 2 because I want to cut halfway through on one side, halfway through on the other. So I'm going to go 3/16. I'm going to use a 1/4 inch end mill. And that's fine. Outside of the cut, tabs. Yep. Add tabs. The tabs, I'm doing it from both sides, so I only need to be 1/8 inch total. So it's going to be a 1/16 of an inch on one side, 1/16 of an inch on another. Edit tabs. We're going to throw 1, 2, 3, 4. Just clicking where I want those. And we're going to calculate this. This is going to be my side 1 profile. Cut 0.25 end mill. So basically cutting halfway through on the side with my 1/4 inch end mill on the outside of the line. I've got a tab half the size of the tab from the front side, the other half the size of the tab from the other side to create an 1/8 inch tab all the way around. Using, got that named. Okay. On side 2, I'm going to go ahead and delete this here because I want to take the profile for side 1 and I want to copy it to the other side with those tabs. And that way, when I create the profile toolpath for this, cutting through halfway on the outside of the line, when I create or add the tabs to the toolpath, it's going to throw those tabs in there already. This only needs to be a 1/4 of an inch. I got to go back and change that to the other side too. I do not need a 1/2 inch tab. Side 2, profile cut. .25 end mill. Nothing's changed as far as the 2 profile cuts go, except for on side 1, I do not need a 1/2 inch tab. Just a 1/4 inch tab is fine. Really don't need a 1/4 inch tab, but we'll use it. All right, so let's go ahead and let's close this up. Let's get everything organized. So my board alignment holes, that's going to be one of the first toolpaths I run. That's a 1/4 inch end mill. My flat area clearance pocket is a 1/4 inch end mill. So those 2 files will end up getting saved as one file. They'll run together. My profile cut, even though it uses the same end mill, it's always last. Okay, so it'll run last. My finished bit, these 2 will end up running together. They use the same tool. One is doing the outside edge. The other one is doing the inside edge. Now, from the looks of that, I've got quite a bit of a amount of meat out here. Let's go back in here and let's see here. I guess I did offset out that far. Okay, that's no problem. So let's go ahead and preview these cuts and see what we end up with. Preview the all toolpaths. That round over looks much better. Much better. See, it's not an end or an edge cut, so you actually get to see the cut a little bit better. It's crazy. Okay. All right, so that's going to be my side one. Now, even though that part of my hole is pocketed out here, there's enough of a hook right here that it's not going to move because the alignment pins are not clamping pins. It's not going to clamp that way. It's going to get, you know, clamped down with clamps or double side tape or what have you, you know. So there's enough of a circle here that it actually wraps around more than halfway, so it will actually clamp and it will pull into position just fine. So I'm not worried about that at all. And then side two, we've just got the magnet holes and the profile cut on side two. So we will preview the visible toolpaths there. Okay. And so this will be my lid. If I was upright. Spin around. It's mirrored because I flip along the y-axis. So this will be my lid. A nice, just a very subtle. It's not, you know, this model is scalable. I could scale it up to any size, but this is just a nice, just to give the lid of the box just a little bit of something, a little detail. So it's not so plain. And just a nice little box detail in there. And my, you know, the 16th inch and 16th inch tabs for an 1/8 inch tab. For a project this small, my tabs really only need to be a 1/16 of an inch thick all the way around. They don't need to be a full 1/8 inch thick, but, you know, whatever. I will leave it at right now, I will leave it at a 3/8 of an inch lid. I'll see what the box looks like and everything. And all. And if I do reduce the size down, I'll let you guys know. Oh, shoot. Hold on. I left Mike's question up there. Sorry, guys. Mike's in the way again. Yeah. What am I trying to say here? I will leave it at 3/8 of an inch and see what the lid looks like, see what the box looks like in its entirety and everything. If I'm happy with it and everything, I'll stick with it. But if not, I'll most likely end up making this lid a little bit smaller. I'll probably end up taking it down to 1/4 of an inch. Now, there are a couple of ways that I can do that. One is I could drill my holes a little bit deeper, knowing that I'm going to take 1/8 of an inch off of this. And I could just do a pocket cut, you know, across this surface and mill that off to bring that lid thickness down to what I want, you know, rather than trying to actually just, and rather than milling, you know, like taking a piece of wood that's already 1/4 of an inch and then trying to, you know, work with it and all without it flexing or bending or, you know, what have you, twisting or warping or bowing or whatever the case may be. I don't know. I can just do a pocket cut. You know, I can mill my holes a little bit deeper, 1/8 of an inch deeper, knowing that I'm going to take 1/8 of an inch off this side too. I can add a pocket toolpath that'll come in and mill it down to size, you know, drill my holes to the proper depth, you know, that 1/8 inch that I want, and then my profile cut. So I can reduce the thickness of this very easily with a surfacing toolpath, you know, a pocket toolpath to surface it down to whatever thickness I want it to be. I'll see what thickness that is, and I'll let you guys know in another class. Okay, so we have our lid here, nice little decorative design, using not the greatest vectors in the world to create a model, but it is a scalable model. It can be scaled up and things. You know, but with it and everything, we've got a nice, you know, model out of it. That model, I could modify it and scale it up to whatever size I want. If I want a piece of wall art to hang on my wall, you know what I mean? Depends on, you know, what the case may be. So we got our box lid, and then follow that by our preview all the toolpaths. Follow that by our box base. This box base is going to be about 1.5 inches. It's going to have magnets in it as well. So it'll pocket out. It's going to pocket down about 1.25 inches is how deep I'm going to have it. It'll end up flocking the inside or felt, one of the two. It all depends. Might put a nice little hunter green flocking in there or something. Kind of jade color, you know, whatever the case may be, because it is an oriental box after all. Whatever color I can get my hands on to tonight. And but hopefully, I know it was long. I mean, heck, we're going in, we're about 15 minutes away from 11 o'clock. It's past everybody's bedtime. But hopefully that hopefully you guys enjoyed it, or maybe picked up something, you know, about modeling. Maybe, you know, just something about something. Maybe you got something from it. Hopefully you did in 7 to 8, 8 to 9, 9 to 10. We're at 3 hours and 31 minutes right now and 40 seconds, the countdown clock says. So hopefully you were able to get something out of it. And all. Unfortunately, I wish that we could show a profile side, like with the actual, what the profiled side would look like. I'm not 100% settled on that bit for the base. I will find the bit for it that's going to give me the ideal look that I want. I will share the information on that bit. I will also, when I carve this project, because this is one of the projects I have to carve for the woodworking shows anyway, when I carve this project, I will film it. I don't think I can do it live. One, you're not going to sit here and want to watch it live, because Mike, we're going to answer your question before we hang up. It is a record. It's a record. It's a record. But we're going to have, oh, you're asking, is it a record for the longest class? Probably so. Who knows? Mike, you had asked earlier how long it would take to make this project. We're going to find out right here in just a moment on both the lid and the base and stuff. But like I said, I'm not settled on the bit yet. But when I find out the information on the bit, I'll share that with you guys for sure. And I'll take the time, and I'll record the setup and carving of this. This would be a good project to record and everything. And then I'll share that with you on Spindle TV. It won't be live because I don't have internet signal out there anymore until I get my new antennas, my new bridge antennas and everything, or bridge signal. Anyway, centers and receiver. But I'll share it on there, and that way you can, you'll at least have a video of the machining just to see how I approach it and everything. All right, let's take a look real quick to answer a final question as to what the machining time and everything would be on this. Now, the machining time is based on my speeds and feeds and my machine's rapid rates and everything. I have a DWC digital wood carver 2440, so this base magnet holes, the inner pocket, the profile cut, the 3 passes on the profile cut, based on that bit and everything, we're looking at about 24 minutes on the machining of the base. 24 minutes. Not bad. Okay. Not bad. I'm happy with that. On the lid, two-sided lid, I believe it will show me the time for everything. With the wasteboard alignment holes, we got our lid magnet holes, our profile cut on side 2, the board alignment holes, the flat area pocket, and the modeling and the profile cut on side 1. We're looking at a total for the little lid about an hour and 44 minutes, and the lid, like flat area pockets, 1 minute. The 3D finish cut around the edge and the surface with that 32nd inch bit, that 64th inch radius bit, an hour and 40 minutes just for that. And 1 minute on the profile cut and 1 minute on the profile cut. Magnet holes are less than a minute. Flat area air is about 1 minute and 9 seconds. So the majority of this is the 3D finish with that bit. You're looking at an hour and 44 minutes plus 24 minutes. So you're about 2 hours and 10 minutes in its entirety for this project and everything. Andy, can you change the rapid rates? No, the rapids for the CNC machine, the maximum rapid is 150 inch a minute for my machine. So no, I could go in and alter my bit rates. If I look at my 3D finish bit, which is the one that's consuming most of the time, if I look at my 3D finish bit details, my bit is stepping over 8%. That's what I want for my step over. I do not want to have to do very much sanding or cleanup or anything. It is running 45 inches a minute. I could increase that, but that's a 32nd inch tip bit. Very, very, very fine tip bit. And I could run that much faster. I could run that 65 inches a minute and all and really reduce that time 75. But I want to try to get the best detail as possible. So I'm not going to rush that. But even, you know, if I were to change it, maybe speed it up by 10 inches per minute, I could probably knock about 20 minutes or so off that time or what have you. I could change my step over, but then that's going to give me, you know, areas that I have to clean up. And all. So, I mean, I could make changes. I could make changes in my plunge rate and all. I could make changes in my step over. I could if I wanted to. But for a box like this and everything, I'm okay with a 2-hour run on that lid. It's a small lid, but or the 2-hour overall project, an hour and 40 minutes, hour and 44 minutes. I'm okay with that. But I could go in and I could optimize some things probably a little bit better. And all, I'd have to look at it and see what would be my best. Because if I speed things up, then, you know, I'm sacrificing detail a little bit. But now my bits are CRN bits. I could run them at high speeds and still get detail, but it's going to mean I'm going to have a little bit of cleanup to do. Right now at my speeds and all, very little cleanup that I have to do on my carvings and everything. But yeah, I could make changes. And everything. So not bad. 2 hours and 10 minutes. You know, 24 minutes for the base and about an hour and 44 minutes for the box. All right, guys and girls. So hopefully. Oh, wait, Andy said, not what I meant. I am talking about like when you are surfacing in one direction, then when you're surfacing in one direction, the return rapid rate. Yeah, the return rapid rate. The rapid rate is what I'm talking about with the rapid rate, Andy, is when the router is not carving, when it's moving from one place to another. The rapid. It's 150 inches a minute, and that's the maximum rapid on the 2440. And so that's what it's already set for. It's maxed on the machine. So Ronnie asked a good question. Ronnie, real quick, Ronnie asked, you know, hey, what would you charge for this little box? Well, to be honest with you, I probably charge about similar to what I paid for the box from the Vatican City and all. It was about 65 euros, which is, I don't know how much that is US dollars, but I'd probably for that little box and everything, with the flocking and all that, my magnets are going to cost me 25 cents. I'd probably be around $50. $50 for that box. That's where I'd probably be. All right, everybody. It's 10:53. I'll give 2 more minutes for questions. If any questions pop up, now's the time. If you got there's the last question, and then we're gonna say goodnight. All right. Good night, Mike Smith. Merry Christmas to you too, sir. And Merry Christmas, happy holidays to everybody out there. Hope you have some safe holidays. Enjoy your week. You won't hear from me until after the holiday. There will not be a class next week. That's why we did a class tonight. But be safe, have fun, and all that stuff. All right, everybody. Until next time, I'll see you soon.